Well, David, thank you again for joining us today. It's a real pleasure to sit here with you. I thought we could begin at the very beginning and just ask you when and where you were born.
Okay. I was born in Cincinnati, Ohio, and that was December 18th, 1951. Even that's interesting. I was not supposed to be born until February of that next year. And through my mother slipping in some ice in Ohio, I was raised in Ohio, born in Cincinnati, it saved my life, in fact. So I was absorbing embryonic fluid, had an allergic reaction to the whole thing, and I would have not survived that except for my mother actually falling and saved my life. So being born premature, December, at that time, I was in an incubator for about 3.5 months. So.
Could you tell us a little bit more about your family of origin, your parents and their primary activities?
Yes, my father had a wide variety of careers, I found out later, but at the time that we lived in Ohio, he worked at Autolite and later General Chrysler and General Motors. He did combinations of things. He was a mechanical engineer. He also was familiar with metallurgy. He, in my later years, I found out that he did a wide variety of things. He was a trapeze artist.
Really?
Yes, and worked on a fishing boat, and so my father seemed to love a lot of variety in the jobs that he held. My mother was very much a homemaker at that time, and she was born in Cincinnati. Also, I found out later that my great-grandfather, my grandfather, my mother, and myself were all born in Cincinnati, Ohio. So very much, I grew up blue collar. My mother had not completed high school. My father completed high school. And I had 3 younger brothers. I was the oldest of 4 of boys. And because of the automotive industry changing very quickly during the 50s and 60s, we ultimately ended up in a suburb of Detroit, Michigan, Roseville, Michigan, where I spent my junior high and high school years.
Were there plant closures in Cincinnati, and so it was moving to a different
That's correct,
plant?
yes,
Okay.
yes. Yeah, absolutely correct. And so things kind of compressed around the Ohio area and migrated north. He worked in Toledo for a while and ultimately Roseville, Michigan.
Oftentimes there's, in households, there will be a predominant or a set of dominant themes in a household, like religion or learning, politics, mathematics, music, things like that. Would you say that there were some prominent themes in your household along those lines?
Yes, absolutely. My father was born in Germany and came to the United States when he was about 13. And so that side of the family, my father's side, was all Catholic, so I was familiar with all of that. But my mother took the responsibility for myself and my brothers. We grew up Methodist. But what else you alluded to was just music and some other things. And so my mother always did have music playing around the home. And I remember the 78, Glass, records, and a lot of the music from the 40s, and we grew up with music playing in the home because of my mother. But I think one of the more important things is that what they really tried to instill is that we were capable of just doing anything that we really set our mind to. That was very important to us. And the other thing that they really thought was quite important is that it wasn't so much important what we did, but that we would do something that we loved doing. So they would, because then we would have a job that we would just love to go to, and through our enthusiasm, probably be better than other people at that job. So that was something that was very important in our house, and I tried to do the same for my sons when I raised them.
Could you talk about, I guess, in Ohio, what your sort of primary school educational experience was like? Did you enjoy school? Did you take to it? Did you not?
I absolutely loved school. I just couldn't get enough of it. But you know, for me, at school was not only was the going to school, and I don't know, it's more like a sponge effect. I just tried to do everything I could possibly do. I just loved learning, and I loved reading, and because I was the oldest, and because my next brother wasn't born for another 4 years, my mother got to spend a lot of time with me. And part of what that led to is I was doing a lot of reading before I even entered kindergarten. And that love of reading has stayed with me even till today. And there's many things. It's like, you know, I mentioned that I fly airplanes. I didn't learn how to fly airplanes by reading. But there's a lot of things I could learn by just simply reading them. And so ultimately, computers and technology and electronics, there's a lot of reading you can do, and yeah. But what else happened is this was outside of Cincinnati, where I grew up. I grew up in New Richmond, Ohio, and in fact 7 miles outside of that. That was a farming community, and at that time they were growing tobacco and a lot of corn, and because it was in the town New Richmond itself, at that time there was probably 500 people in the community. But it led to something that I believe was also important in my life, and that was we had a lot of alone time. We had a lot of, we had 13 acres. By the way, we were the city slickers in the area because everybody else had 1,000, 1,500 acre farms, and here we are with 15 acres, 13, 15 acres. But we had the goats and we had the chickens and we had those kind of things, and grew up with an acre garden where we supplemented our food source. And there was bartering going on. But more importantly, because we had our own time, we created our own toys, we created our own environments. We did the proverbial string in cans, and we flew kites, and very much blue collar. So it wasn't like we had a lot of, I didn't realize until later, we only ate meat a couple times a year. We ate meat a couple times a week because it was a money thing, but we never knew that growing up. But we created our own toys. We created our own entertainment. We ran down to the creek that was at the back of the property and explored and those type of things. So we learned how to think for ourselves and how to be by ourselves and entertain ourselves.
Do you relate that experience very directly to your subsequent work in designing and making things?
Yes, absolutely. Just as I was able to enjoy the creative process when I was younger, because there was not a lot of outside noise. There wasn't a lot of outside influence. Family members, of course, and school. But absolutely. I learned to love the quiet time and the reflective time, and times that I could be. Later, I learned to be, very creative. But
does anything really stand out to you from that time that you designed or that you built that just really stands out in your memory as significant?
Yes.
Or pronounced?
Yeah, there's a couple interesting little things. As early as the third or fourth grade, because I was reading quite well. I didn't know it at the time, I was reading a bookmobile would come around, which was the library.
Okay.
And I was reading junior high school and high school books, which initially they wouldn't want to let me check out. And so I had to, and by the way, being self-taught, I didn't know the pronunciations. In the fourth grade, I think I called a capacitor a capacitator or something like that. But I had to convince them to allow me. No, David, you can't check that out. But I had to convince them that I was capable of reading that and getting information. But I ran around school in third, fourth grade with motors and light bulbs and those kind of things. And probably the couple of things that I remember very, very early is at that time there was a movie that came out called The Time Machine by H.G. Wells. And they talked about time travel. Well, in this perspective of a fourth grader, I was trying to think about what you would do to make a time machine. So the projects of space were very much in the forefront of what we were being exposed to, both at school and at home. And so I had enough knowledge to know that you had to have oxygen in space and that vacuum would present less friction. So I came up with this idea, and by the way, to make the calculations easy, I just did a tube that was a mile in circumference. You took the air out of the tube, and then I would have an oxygen, like a scuba diver's tanks on my back to be able to be in this environment and put myself in a projectile. And interestingly enough, the projectile would be supported by electromagnets. And then I just had a simple motor and a little switch that would switch the electromagnets on and off and then accelerate the projectile with me in it. And then by skipping magnets, so to speak, accelerate the. So that was my way of thinking about, and so I presented to some teachers, and some teachers were like very, very enthusiastic about it, and others thought that I was a little strange.
It's essentially Elon Musk's Hyperloop, isn't it?
It's the oddest thing, and I may have drawings of that from that time. But the other thing that was important is in my years of going to school, there were a couple just teachers that just really made a huge difference. By the sixth grade, I started with very, very of my own designs, like radio transmitters, a theremin which creates music, were of my own, very, very simple. They were at that time. I had learned tubes younger, and then transistors were coming into play. And my sixth grade teacher, I remember very well, James Putman. He had courses in electronics that he was not completing, so he gave them to me. And I was completing these courses. And the other thing at the time is there were some kits from Bell Laboratories, and they had some of the early, they were more for high school, but he had gotten his hands on them. And there was one that created just the first speech synthesis and just did vowel sounds, A, E, I. And so I built that. I made my own photocells. You had to have a high temperature oven, which my father, working in the automotive industry, got on loan a little. So I cooked up some, photocells in the sixth grade, and they worked. So yeah, it's.
Were you doing all of this work at home? Did you have a dedicated electronics laboratory in your home? Was it your bedroom?
Yeah. Later, more of a later there was the dedicated room that was in the furnace room with the layout. Right. But yeah, I had a kitchen, an old kitchen table that I could do my experiments on, and so it's interesting. My parents were very, very supportive, but yet really didn't understand what I was involved in and couldn't help me in that regard. But they helped me by being supportive and supporting some strange things that were starting to happen around the house.
And I think you were mentioning earlier that you were also encouraged by a grandparent into your
yes, yeah. My
interest in
grandfather
electronics.
So he bought me a crystal radio kit when I was 7, and I really did wind the coil and sand off the varnish and make the little slider for the inductor. And now my father he didn't know what he was doing, but he built a dipole antenna that had to have enough length and wire, but we had the room in the country, and so it ran. I was just fascinated that I could listen to radio stations and there was no power, no battery, it was the old crystal radio set. And my grandfather, my mother's father, had the first Polaroid camera. He had the first stereo tape recorder, of which we just listened to jets fly back and forth and trains. There was no music that was in stereo at that time. And he had a big Lionel train set. And he just said, electronics is going to be the wave of the future. And if you work in electronics, you're going to be like having a great time. So I was exposed to that 7 to 14 or 15. He died a bit young, but later I also found out he taught at a museum in Cincinnati, oil painting and charcoal, all this art drawing, which happens to be a really strong hobby of mine, and I enjoy oil painting as well. But yes, he couldn't. His influence was just very, very dramatic. And by the time I was 13, we had 14, we had moved from New Richmond, Ohio, to Roseville, Michigan, and that was a suburb of, and is a suburb of Detroit. And so I was buying parts at the local TV shop, and what that led to is I was offered a job by the family that owned it was Telestar Television, and it was on Fraser Road in Michigan. So I worked from the age of 13 to maybe 16, fixing radios and TVs. Yeah.
And well, just to go back to ask a couple questions, with being such an early and voracious reader, was it primarily through the library and the library's bookmobile that you were accessing books?
Yes, absolutely. Boy, I would have loved the internet in those days, but yeah. But yes, absolutely, bookmobile. And occasionally, like Mr. Putman would get me some information from, like a kit from Bell Labs or a course or something. But yeah, for the most part, bookmobile.
And you were reading a lot of technical electronics-oriented material, it sounds like. Were you also reading fiction? Was science fiction a part of your world?
Yes, something that was very, very important to me. So it's interesting. I had chores around the house, and for the chores that I did, I'd get $0.25 a week. And so I'd save up 4 quarters, and then once every couple months, we'd go into a larger area to do shopping. And I don't remember, it's Batavia, Ohio, and I would buy for $1 a book that was Tom Swift Jr., because there had been a senior before my time, but in the 50s, and Tom Swift was a series of books about a 19-year-old that was doing inventions. And so I really and so it involved electronics, and it involved an atomic submarine and a robot and all these things. And I would have the book finished before we had I would buy the book, sit out in the car and read the book. And by the time the shopping spree was over, whatever was being bought, and going home, I had already finished the book. So Tom Swift, and it's like I wanted to contact the author at some time. Junior, and by the way, the senior had written the books, and the son became the writer of the Tom Swift Jr. series. And it had such a huge influence and impact on me, more than I can even really fully comprehend. But there was an excitement, a hope, being part of all of that, inventing things.
Well, that's great. So it was in Michigan that you attended high school.
Junior high and high school.
Yeah. And how was your experience there?
Changed quite a bit. So coming from farming community to a suburb of Detroit, things got serious really quick. And everybody was much busier in school, and but again, there were a couple teachers, typically science teachers, and I started, getting real serious because I wanted to go to college, and I was taking, the things to prepare me for college. But again, a couple teachers were very important to my development. There was a Mr. Roberts, I don't remember his first name, he taught science, but he was also in charge of this photo lab. And I really got involved in photography for a while, so much so that I borrowed my first $50 from my father to get a Boolean Enlarger, and I set up a darkroom in Michigan. And that quickly turned into a business developing all the neighbors, at that time, black and white film, and also slides, color slides. Not much more than that in that time. And so that business paid off the Boolean Enlarger, and that photography and that experience in the darkroom stayed with me for quite a while. And the other thing at that time is that the neighbors found out that I worked at the TV shop, and all of a sudden I ended up with a basement full of like TVs and toasters and stuff to fix. And ultimately my mom was going like, okay, David, this is kind of like, you get some of this fixed and not take on any more projects here for a while. The other thing that happened very clearly during that time is not a troublemaker, but if anything was happening weird in a neighborhood, they would call my house. During that time, I designed one of my own designs. It was a tube transmitter, and I remember very clearly that the power output was from a 50C5 pentode tube, and I did something interesting. I connected a 6EA8 tube, which I used as a screen modulator, to put voice on it. So I had a friend that I had met in junior high, Keith Dodsworth, who him and I would buy stuff from surplus, and we had a radar transmitter sitting in Keith's basement that we had refurbished. Later, much to our chagrin, we found out that the frequency was the same as the police band, so whenever we turned it on, we were kind of blocking the police band at the time. And so what I was alluding to is that I built my own transmitter. And so I would talk to Keith on my transmitter, and he had changed the frequency of a CB radio to be able to talk on, and I forget whether it's 20 meters or what frequency that is. So we talk back and forth on our radios, but what happened is my antenna was just pointing right. It was a much smaller suburbs, much smaller yard. I had a dipole for 40 and 20 meters, I believe, and it was pointing where all the telephone cables run. And what I didn't know is they didn't put the shield, at that time I didn't know, they didn't put the shield back on the box. So every time I talked on my transmitter, if you picked up the phone, whether anybody had dialed you or not, you could hear me talking on all the phones in the neighborhood. So they'd say, hey, is that David talking on the, And then I had won a science award for a science competition, a science fair. And so I get to go step back again, and we went to a University of Miami. It was in Ohio. I don't remember, but I saw Tesla coils. And I have a visual memory that I've relied upon. And so I looked at these Tesla coils creating these huge sparks that looked like lightning. And so around the time in Michigan, from my memory, I built a Tesla coil and created these huge sparks, and my younger brothers were running around the backyard holding fluorescent tubes that were lighting up, And what I didn't know is, well, a Tesla coil has a spark gap on it, and when you adjust a spark gap, you adjust the spark gap, and it tunes there's an inductor and a capacitor. I made the capacitors out of glass and put them in an aquarium with oil, and I rubbed aluminum foil on the glass and made the capacitors for this Tesla coil. But it's a spark gap transmitter, and that transmits on all frequencies. And so all the televisions in the neighborhood turned black and rolled while I was running the Tesla coil, and nobody ever figured it out. My brothers years later laughed about the fact that my dad would go over to because it was tubes, and hit the TV set, and then it would start working again, because before the oil started I could only run the Tesla coil for maybe 15 seconds or 20 seconds, and the oil would get warm and start to boil.
Right.
And so the TV would start working again. So my dad would pound on the TV and it'd start working. But my brothers were like hearing this spark, this Tesla coil running and going, gee, our dad didn't associate like this noise downstairs that Dave's making with the television going black. But and chemistry, and just was involved. And the other thing is, quite honestly, my schoolwork, I did enough to get by. See, I developed some bad habits, and that was electronics was all encompassing. And then there was, I'm so excited about it still now, and chemistry and photography, and I spent all of my time doing that, and as little time as possible is doing the traditional schoolwork. So, yeah.
Yeah. Well, so you worked in the television and radio repair shop throughout high school?
For about for a couple years in junior high and a couple years in high school. And what's interesting is I remember when I was 5, 6, 7 years old, a TV repairman would come, and we had the old, 50s TV, black and white, and they would pull tubes out and in. And even at the age of 4, it was, my mother talked about this. I would take shoe boxes, and they would help me punch holes, and I'd put tubes in the shoe boxes and play with TV parts and stuff. So I don't know what that attraction was, but I couldn't get enough. I would stay up as late as possible in the evenings and read or do whatever. It's just so exciting.
Well, as high school was coming to a close, how were you thinking about pursuing your passion for electronics?
Yes, I had planned on going to college. There's a couple things that happened at that time. The draft was, I graduated, I started school a year late because I was born in December. Mm-hmm. So I graduated in 70, and the Vietnam conflict was going on at the time. I was a low draft number, 13, 14, 15. And something else interesting that not many people are aware of is that Nixon had made college exempt for the year you were in. This is 71, and you could finish that year, but you couldn't continue school. So it was no longer that I would start college and be able to continue until I finished. It would be just that year. Yeah. What else happened is that really the focus at home was very much work, home, and not much thinking about the 4 boys because it was just surviving. And to be fair, my father left Chrysler Motors when I was on a scholarship program in my junior year, and took a job at General Motors, and so I lost my scholarship, and there was really no discussion about that. It was just so because of me reading magazines about electronics, popular electronics in particular. They said if you wanted the best electronics education, that you would go in the Navy, because being shipborne for the most part, they would have to repair all levels, depot, it's called depot level, I level, and O level maintenance. So you would learn all levels of technology, unlike some of the other branches. So, interestingly enough, because I had been I didn't know this at the time, but I placed very, very highly in the scores at Detroit in the where I took the entrance exams, so much so that 7 years later, I was in for 8 years, my name was on the wall, and I walked into the recruiting office, and I see my name on the wall, and I said, David Hampton. He goes, yeah, do you know him? He's like scored the highest, of the entrance exams here in Michigan for the last period of time. I said, yeah, that's me. I was never told about that. But anyway, electronics, Navy, I signed up. I went in the military, and it was January of 1971. And because of my preparation for college, it led me to be able to it allowed me to do very, very well in the entrance exams. And I just thought, you got to pick what you wanted. See, so they said, David, you should pick either nuclear submarines or naval aviation. Well, it was based on my scores. I didn't know. that I thought everybody got to pick what I was 19 years old. So, so I headed for the naval aviation field. You know, there were entrance exams. I'm kind of oversimplifying it. There were entrance exams, and then there were other exams, and there was the boot camp and some other things and more testing. But ultimately, I ended up in naval aviation, and I was really, really quite heartbroken about the whole thing of not being able to attend college.
So it would have been the case that had you not enlisted, you would have been drafted.
No, absolutely. In fact, what happened is while I was in boot camp, my parents sent me the letter from the Army saying that I would have been, that I was being drafted. Oh, so, because the timing of everything was such that they hadn't finished the records. That, you know, I enlisted, went in January, and then sometime in January, they just thought it was pretty funny that they sent me this letter from the Army. Yeah. So.
So where did you? So, why did you choose avionics or that route rather than the nuclear Navy?
It's called a little bit of a problem with claustrophobia.
That's a very valid reason.
Right, and I had, my father had flown small airplanes, and in fact, some of the earliest dates of my father and my mother were flying down the Ohio River in this float plane that he would rent. And so I had always had an interest in learning, or for a very long time had an interest in learning to fly airplanes. So I just kind of was more interested in the aviation side of things. At the time of entering the military, little did I know that although being in the Navy, I really never ended up on a ship whatsoever. I was either part of an air crew or land-based or whatever.
Well, could you talk about your sort of immersion in electronics and electronics training in the Navy that led to what I think was the mainstay of your early activity in the Navy, which was as an aviation electronics technician for the Lockheed Orion aircraft.
Right. The P-3 Orion, which is interestingly, at that time, the training for all of that happened here at Moffett Field, not far from here. But through testing and placement and scoring I didn't know at the time, relatively high, I was able to choose duty stations. And again, when you're in it, you accept things as just kind of normal. That's what happens for me, but later I found out it wasn't the norm. And I asked for Barbers Point, Hawaii. And I had even instructors that kind of laughed because the chances of that happening were very slim. In my case, my first duty station that I was assigned to was in Barbers Point, Hawaii. I became part of VP-1, which flew the P-3 Orion, which had a lot of electronics on it. And the P-3 Orion, not only is it a anti-submarine warfare aircraft that served for a long period of time, but it also did missions of reconnaissance and surveillance and those type of things. 4 turboprops, a crew of somewhere between 11 and 13 individuals. And so I did a lot of, there's A schools, B schools, and C schools. And I signed up for 6 years initially because they guaranteed at least 2 years of schooling. So I thought, yeah, that's a nice, a nice compromise between, and I got to, and I had more in the way of choice. But you had to qualify for that as well. But ultimately, VP-1, and this is during the Vietnam conflict, and I became part of a test. So I was a crew member on the P-3 Orion. I sat port aft observer. And I was the only electronics person on the plane, and not much later after joining VP-1, they did a test program where they had this idea that the ATs, aviation electronic technicians, could potentially repair aircraft in flight. And I was one of the first, probably 15 ATs that started repairing during missions aircraft electronics in flight. Sometimes it's rather precarious because you can't turn off power to certain critical systems. And what this led to is that the P-3 Orion had a radar in the front and back, 360. But you were not allowed to be out on a mission without any radar. So we would, so if I repaired electronics in flight, where there were certain critical things that you could not be on a mission without them being functioning. And that was some radio equipment, some particular navigation equipment, radar equipment, and so on and so forth. So the P-3 Orion could fly missions 15, 16, 17 hours, and so you get out to perform a mission. If something went wrong, all you'd have to do is turn around and go back home, which led to this program of the Inflight electronics technician. And it became a success, and so much so that each crew then later, and for many years after, was assigned a in-flight electronics tech.
What was, were there computers in the aircraft at that stage?
Yes, there were, and they had drum memories, and the RAM was a the names elude me, but it's core. There's core memory.
Magnetic
So
core
it's
memory,
yes,
yeah.
Absolutely correct. And there were tactical. There was a tactical coordinator station. It was all electronics. There was the navigation equipment, the radio equipment, the autopilot, the crypto gear, and it's interesting. People talk about a top secret clearance, and having one, I know that it only is used during the time that you need it, and when you don't need it, you don't have it anymore. So for crypto access, I did carry a top secret clearance, but there was also the anti-submarine warfare type of where they launched sonobuoys, and they analyzed the spectrums of that would be received of the information in the water, the spectrums of or the signatures of things that were in the water. That equipment was all electronics. So for the time, it was a rather sophisticated aircraft.
Was that had you been exposed to computers prior to that?
I had been exposed in high school in a Algebra 2 class to the teletype, and it was connected to the computer. I would think for a minute and I would remember the name, but it was on a campus and it was over the old acoustic modem. And I remember typing in a program that just simply converted Fahrenheit to centigrade or centigrade to Fahrenheit, and being exposed to that paper printing out. And very, very, very fascinating, yes. But as far as anything more sophisticated, the Navy was my first exposure to that. And really my first exposure to learning ones and zeros and Boolean Algebra and those type of things.
And what was your response to it? I mean, was it something that you took to, or like you did with all of this electronics activity, or?
Well, here's what's interesting. At the time, I learned what I needed to learn, and it was fascinating. But the reason it didn't go much further than that is that it was just a huge expensive system, and so I saw no correlation between that expensive equipment and something that I would ever be touching in the foreseeable future. But yes, it was of great interest, but I was not quite as enthusiastic as I was for the things I'd be able to take home with me and get involved with and make part of what I deal with.
Were you continuing your sort of what we might, for lack of a better term, call your hobbyist activities while you were in the Navy?
When I was land-based for a period of time, I did start oil painting, I did start playing guitar, and electronics. It was hard to really set up much of an area to build too much, but I kept up with popular electronics and popular science and those type of things. But the Navy was really, other than the electronics that I worked on for the military, it was a period of time where I started doing other things, and I studied the Japanese language before being stationed in Okinawa, and I studied the Thai language before being ultimately stationed in Thailand. And I learned, I owned a Thai restaurant when I was stationed in Thailand and learned how to do Thai cooking. So it was kind of a cooling off period in some ways. Electronics was very much there, but I couldn't pursue it because I was largely not in control of my life anymore. I could be in the Philippines one day and in Thailand the next, and then all of a sudden be in another place so in a matter of days or weeks, all I did was carry around a couple duffel bags for a while.
Well, for how long were you stationed in Thailand when you had that restaurant?
Right. So Thailand, it was supposed to be my last duty station. I was going to be there for 3 years, and I was there during the time that the conflict was closed. It was over. So I ended up being there at that time about a year and 6 or 7 months, which led to me then going back to my final duty station when where I was stationed was actually a Thai naval aviation base, Utapao, and there was a large Air Force presence there, but only 15 of us or 20 of us in the Navy there. But yes, so I was there about a year and 7, 8 months, and then the conflict was over, and we quickly left Thailand.
And that's when you went to San Diego.
San Diego, VS-41.
And there it was that supporting a different aircraft, the Lockheed Viking?
Yes, the S3.
Similar mission or?
Similar mission. Now, there's a huge difference, though. I would not be a crew member on an S3A. It was a smaller aircraft, and it was carrier-based. So the P-3 Orion, being a 100-foot wingspan and 4 turboprops, was always land-based. So that meant, even though I was in the Navy, I was land-based overseas and such. Now, S3A, VS-41 was a training center for electronics and flight and all of that that applied to the S3A, and that was in North Island, which is, right, it's San Diego. And much like Moffett Field here was the training center for VS-31, that was the training center. VS-41 was a training center. So I was in support of the electronics in reference to the training center there. By that time, because everything was happening so rapidly, I was promoted 6 pay grades in a matter of 3.5 years. That had a lot to do with test scores and what they considered mission critical and what was going on. So by that time I was managing an avionics shop, and I was not running out to the airplanes so much, and I was no longer a crew member. In fact, I lost being a crew member when I was assigned to Thailand as doing both eye-level and depot-level maintenance for mission critical electronics. Yeah, so San Diego was a training for the S3A.
And was it, had you decided, you initially enlisted in the Navy for 6 years. You were in for
8.
8. So somewhere in
I enlisted
San Diego.
Before San Diego,
Before
I enlisted.
San Diego, you enlisted for another 2.
Well, that's that's a little bit of a delicate topic, which is interesting. What happened is when you enlist for 6 years, they guaranteed this bonus that when you would be released, it was 10, 12, 15, I've forgotten the number. And I was getting ready to get out after 6 years, and they did not pay that bonus. There's a change of, something happened. I found out later that a bunch of people took that and took it to court, and they were ultimately paid. But here I was ready to get out of the military, prepared to have a certain amount of money in my hands to help that transition. But ultimately that didn't materialize, and I was overseas at the time, and so I did another a 2-year stint. So that totaled for 8. Yeah.
And but as that 8th year was coming to a close, were you fairly? I mean, some people, make the Navy their career.
Oh yeah, sure. No, I knew. No,
Were you? Well, tell me about what you were thinking.
I absolutely was not going to be career Navy. It was a wonderful opportunity. It was wonderful in visiting lots of places and learning new languages and cultures. It could have not been surpassed in that way. But as far as electronics went, I didn't have choice. I didn't a lot of choice of what I was doing. So in preparation for getting out, I got my hands on every single book that I could. The Navy at that time was not using a lot of CMOS technology, TTL, all the integrated circuits that were developed at that time. It was wonderful technology, but it was still behind the times. And we're talking 1978, 1979.
Yeah.
And so I just grabbed everything I could to read and catch up on all of these integrated circuits. At this time, we were seeing the signs of the first personal computers. And I'll be very honest about that. I just loved the idea, but when I saw that you were flipping switches to enter data, and that it was very much a tape, and like the first S100 bus things, they weren't doing very much. Mm-hmm. And I saw what could happen, but I didn't know it would happen so quickly. Mm-hmm. It happened much more quickly than I could have ever realized. And I became part of that in my first job after the Navy. But for in San Diego, of which I was there about 2.5 years, I believe, it was a catching up and reading and getting involved with all the things that I loved about technology again. So that's what I used that for.
So could you tell me about what you did immediately after leaving the Navy?
Right, so getting out of the Navy, I could only prove on paperwork that I was capable of technician type of work. And I interviewed at a couple places in San Diego. And interestingly enough, I was always very direct, hopefully not arrogant, but direct. And so I'd interview and I'd say, well, if I do something interesting, or how fast can I be advanced? And some places would say, well, David, no matter what you do, you'll be at this job for 1 year, and then we'll do a review, and so I said, oh, okay, great, thanks. But one of the places said, well, it's interesting you're asking that. I mean, they don't understand. During an interview process, you don't usually ask those questions. But I'm enthusiastic, and I want to give, and I want it to be a mutual benefit. Right. And so I had a place, and it was that I interviewed at. It was called Digital Development Corporation. They made hard drives for submarines. I said, well, David, if you do something interesting or different that deserves merit or recognition, of course we would consider a promotion. So I took the job that actually paid, I remember, $6.25 an hour instead of like $6.75 an hour, on the hope that I would be able to do something of benefit there. So I was there about 6 weeks, and they were calibrating a large hard drive systems. And this hard drive system was very, very different in that it had 255, a large number of heads that didn't move. There was no Manchester encoding at that time, where the clock is encoded with the data for recovery. They had a separate clock track on the outside circumference of the hard drive. But what happened is, by no moving parts, it could survive a lot more, much better in the environment of a submarine. But the access time was very, very quick. You just electronically switch the heads, no movement. So very fast access, very high speed RPM, very large drive. My mind races, and my tongue trips over what my thoughts are. But what was going on there is that large hard drive, and it would take 16 or 17 hours for a technician to calibrate all of these circuits and the heads and the clock track and the phase lock loop. That, it was a long process. So I came up with an idea to make a computerized test set, and much as throughout my career, I don't think about whether something's innovative or not. I think more about whether it solves a problem. And I didn't know it at the time, but it was innovative to create, at that time, the characters came out of a character ROM. And so it was a character set that you could put alphanumeric characters up and numbers and such. But by doing a parallel bus kind of thing, arranged RAM memory, to be able to store custom character sets, so to speak. So the idea was to draw a circuit board on a screen, and through analog muxes, connect whether a DVM. There was a DVM chips were out there, a digital voltmeter, which means I could measure voltage or resistance or current, program the probe to do whatever I needed, flash a little area on the circuit board to connect the probe, and then flash an X at the bottom of the screen, show the calibration point, and just adjust the calibration point until the X flashed. You wouldn't even need a technician for that, and it became more of like 4 or 5 hours rather than 16 or 17 hours. So it's a very long story there.
So you were making to essentially automate and speed up this calibration process.
Yes.
You made kind of a microprocessor based custom tool for doing this calibration.
That's correct, and we nicknamed it the PAT tester, the Programmable Automated Test Set. It was 6502 based, and very, very much, yes, a custom design. And so I found myself being promoted to test equipment engineer, and and heading up a department to get this test set developed and built. So. But now I became recognized as being able to do engineering work, which served as a stepping stone for the later jobs that I held and later positions that I held. It was very much I had to show people what I was capable of doing rather than show the degree that I didn't have. So.
And was that your first outing in creating a microprocessor-based product, if you will?
Yes, absolutely.
Yeah, and you designed it. Did you write
start writing the code for all of that.
In assembly language, or
it was assembly language, and a difficult situation though. What happened is everybody has a better idea. And but anyway, yes, it was the first exposure to really 6502 and developing the buses that interfaced. At that time, you had to just build your own display board and build your own character generator, put it on the display board, and RAM was separate and very expensive, and so on and so forth. So it led to the next year. Job in test engineering, and interestingly enough, only a year or so later, I went to a place, MSI Data, and they were using computerized test sets, not quite as sophisticated as what I was developing at the previous job, but 1802 processor, and that led to a whole bunch of other things.
Well, could you talk about MSI? I read from your CV that they were making handheld computers. Could you talk a little bit about that company and what they were making and your experience there?
Well, what's interesting is with the large battle of trying to convince people about computerized test sets at DDC and going to MSI, they were already on board. I didn't have to battle with anybody to convince anybody, but they were making an 1802, and that is a RCA processor. It was CMOS based, and what that allowed you to do is have it portable. It could run off of batteries. So they made some of the first, and we're talking about 1980, 81, the first handheld data collection terminals. And what I mean by that is it was handheld, battery powered, with some keys on it, and then it had a optical reader, so you could scan barcodes and do inventory control. And so they had already got it. They were on board with all of that. And so I went there as a test engineer and helped to learn. I learned how to set up. Here's what's so nice. I've always had the wonderful opportunities to get jobs where I was over my head. And I kind of sought, I would seek that out, because what happens is they, in fact, without really being fully aware of it, trained me in these wonderful ways that became stepping stones for what I did later. And in fact, I think this is very, very important. I have learned it doesn't matter what you, within reason, what you learn in life, there's at some point in time you'll be able to call upon that knowledge or information. Knowledge and information you get to keep forever, And so nothing is wasted, in my opinion, when it comes to reading and gaining information and knowledge. And it's just all exciting, whether it's music or painting or electronics or. And in fact, I'm going to probably digress a bit here, but what's really important is I made not a mistake, maybe a misunderstanding. I thought that my love was electronics. And don't get me wrong, I love electronics. But what I've come to find out is it was the love of learning, the learning of the discovery process. And I found that same love in writing and composing music, and the same love with painting, the same love, although I didn't mention it much, I play a couple music instruments, but unless you do that a lot, you don't stay very proficient for very long. But all of those things, and flying, like flying airplanes, it is the love of learning and gaining knowledge and being creative with that. And you can be creative in anything. I've always found, whether you talk about motorcycles or cars or airplanes or dentistry or medical, or there's huge opportunities to learn and change an industry by being excited about what's new. And invention, to me, I didn't invent anything that never existed. What it is a combination of knowledge that you gain, and you rearrange it in a different way. And then you present what seems to be a new concept. It's what you've learned. And so by learning something from painting and learning something from electronics and learning something from programming and so on and so forth, I have more things that I combined and can create new ideas. That's what I found out is the most exciting thing of all. So.
Well, it seemed that, the next couple steps of jobs that you had were in the kind of similar vein, from MSI and working on automating testing and, more exposure to microprocessors and programming. And then I think your next job was at a CNC programming, very brief, but then please, I'm so fascinated to see the story of it. It almost seems like then there's it reads like a discontinuity when you go to Western technologies. It seems like it's a change of place, although maybe not that terribly far, up more into Los Angeles region, but it seems like a completely different domain. Could you talk about that?
Yes, I can. And so it's not something that you can easily write about.
Yeah.
But here's what happened. At MSI Data, I was responsible for getting new products shipped out. And I was working with both hardware designers and software designers. And I found something very interesting at that time in probably 81, 82. Is that when something went wrong, when a new product wasn't, had some difficulty, the hardware engineers would say, it's a software problem. And the software guys would say, it's a hardware problem. Well, up to that point, it had been some software, but mostly hardware, you know. And, and by the way, what was else was interesting is that their vocabulary in talking about the same thing was different. So inside of a chip, there can be an area of storage inside of a chip, and the hardware, people talk about those as registers. And because of the way those registers are used, software people may refer to those as a stack. So you could be talking hardware, a register, software stack, and they'd be talking sometimes about similar problems or the same problem and not understand the vocabulary. There was, and this, remember, this is 81. So at that time I thought, if I'm going to be sticking around this industry very long and be able to keep up, I probably need to learn and become as proficient at software programming as I do hardware. And if I could somehow know both worlds, I would be able to solve problems that neither field by itself would solve. Now, ultimately, you know, I'm going to tell you the punchline. I never would have guessed at that time. It led me to be able to develop products that no one else could, that were low cost, because I could trade. The cost of software occurs one time, and that's called, it falls under non-recurring engineering. In other words, you write the code, and once you write it, you don't pay for it anymore. It costs a certain amount of memory space or whatever. And if you put in hardware, you solve it with an extra transistor or chip. You pay for that every time you make that unit. So by having an intimate knowledge of both of those, I ended up being able to become part of what we allude to with that industry, where I started writing video games and ultimately being invited to join a think tank at Mattel Toys. By combining those two disciplines, usually that's multiple teams. And you know what? It works. But it's not the same as being in one head, one brain. So that discontinuity was that I said, I'm going to have to start writing as much software as I can to raise my skills, so that now I integrate at an equal level, hopefully. That was a goal.
It was that deliberate.
Yes.
Huh, interesting. And
Yeah.
so was it the case that, was it more about an opportunity to delve deeper into programming and software than computer games per se?
Absolutely.
Okay.
Yes, absolutely. Okay. I had no idea really about computer games. They weren't, you know, they were popular, but they're not what they are today, where everybody, you know, there's a lot of people who love to start writing, you know, video games.
Right.
But here's also the aspect of it. What I had been involved in is real-time applications, and that's what also is exciting. And that is, the hardware has to run very quickly, respond to human interface, and respond quickly enough. And then the code has to run quickly. It's not like in the early days where you would do a digital commercial and you could like have it render overnight,
right,
and then come back. No, everything was real time. And so the attraction was video games were very much real time. They had to be very efficient. They had to be very small. And here's another analogy. When I started taking my private pilot training, I didn't. Ultimately, the first airplane I bought was not tricycle landing, which is the easiest thing to take off and learn. I mean, take off and land and learn in. I bought a tail wheel, was my first. And the whole idea was that if I learned to fly the airplane, a more difficult airplane, I would be a better pilot from then on. I had seen pilots I had flown with that got a little lazy. They didn't use much rudder pedal in the trike landing because you didn't have to use so much rudder. But if you do something wrong in a tailwheel airplane, you do something called a ground loop, and the plane spins around, right, and then you hit a wing or something and cause some damage. So I was very much focused on the real-time aspect. programming. Here's something else that happened. Because I had such a wide, varied career, this is a weakness of mine, and I had to try to turn it into a strength. In normal corporate, in normal jobs, when you do something well, they want you to do version A and B and C and D and do that. And I've had friends that they spent a career of developing hard drives at Western Digital, for example. That's not me. And so I became also aware that I was having jobs for a period of a year, year and a half. Ultimately, that didn't look very good on a resume. And I had to start my own business. That was part of, and it's just the truth of the matter.
Yeah.
But I became bored easily, and so anyway, so that discontinuity was me. I really did. I promise you, I made a mental, conscious decision that I needed to get my chops up in software, as I had developed as the hardware, if I was going to be in the industry for a very long period of time. That was my belief.
Could you talk about Western technologies and how you became associated with them and joined them?
Yes. Now, interestingly enough, by that time I had such a diverse background that I had to go out and find a job recruitment service, otherwise known as a headhunter, because you can't walk in the front door and say, oh yes, I do RF design, and I do audio design, and I do digital design, and I program, and I, whatever. It just doesn't. So by finding this job placement service, they could represent me. And then, so I interviewed with them. I did this, and my wife was actually part of this, saying, hey, Cindy, it wouldn't be a bad idea if we get somebody else to represent you, because this is, and so Western Technologies was two companies, J. Smith Engineering and Western Technologies, very well known in the toy industry. And they were known for developing, I didn't know it at the time, but LCD handheld games were big at that time. And Atari 2600 was doing quite well. And so I interviewed, and based on my background and my excitement and enthusiasm, I ended up with a job at Western Technologies. Western Technologies was the development company, and the patents were held, and the royalties and such were collected by J. Smith Engineering, so they had a separation of the two companies. And he's very well known as a toy inventor and a video game. And so I was exposed to a version of a think tank. And what was really interesting about this is, after the interview, I came home to my wife and was so excited. They were shooting rubber bands at each other, and they had refrigerators full of soda and snacks, and listened to music, and you could go off, and if you got a little bit bored, you could go off and play arcade games a little bit, and so it was really, really an unusual environment. So I had to so here's what works for me. I had to become familiar with an Atari 2600 very, very quickly. And there was a manual that they had, I think it's a Stella programming manual or something, and I read that, took it home and read it multiple times, and became familiar. And so real quickly, there was a critical routine that in the Atari 2600, you had to put you had to create the vertical sync pulses, the horizontal sync pulses, and all of these things just to get something to display on the screen. So I rewrote that routine and optimized it, and they ended up using that for the basis of all the games. That became the standard that they used. And really quickly, again, within a matter of, and I wrote a game for an in-house development that was being sold to US Games called Raft Rider, nothing of really, but it's what I cut my teeth on. Q*bert was a very, very popular arcade game. And Atari said it was impossible to port Q*bert. Porting is to take a game from one machine and put it on another machine. It would be impossible to port Qbert to the Atari 2600. Here's why I said here's where I earlier said no information goes wasted. Because of my experience at the TV shop as a child, a teenager, I knew the timing of much more detailed than what programmers did. Programmers round things off, at least at this time, and they didn't have the exact horizontal sync pulse timing or the exact vertical interval timing, the refresh time. And because I knew those timings, I was able to take out a horizontal sync pulse at the end of each line, and that saved 3 bytes of code when you only had a 4K cartridge per line, and there were 18 visible lines. And it didn't waste the time, it didn't waste the memory, but I had to hand count all the cycles in between. So I could do no conditional branching, I could do, it was all, and if I made one mistake in coding, the whole picture lost synchronization. But that was the fundamental trick where I never did anything that was impossible. Ultimately, I just did things that were more difficult than most people would be willing to take on. But because of my experience at the TV shop at 13, 14, 15, I had the experience of being able to solve and program Qbert. The punchline for that is that's why not much longer after that, I was invited to join the think tank at Mattel Toys.
May I ask a follow-up question here about Qbert? As an arcade game, was that built, was that microprocessor based when it was the arcade game, or was it all kind of discrete logic boards?
It did have well, there's a lot of discrete logic for the graphics creation and for the sprite creation and for collision detection. But the game was written, if I remember, I may have it wrong. Well, I believe there was a 8086 processor, but interestingly enough, there was like a Z80 processor and a little LPC speech synthesizer of the TI variety, which I ended up using later, that made Qbert do this little.
Oh
yeah. And then there would be a little solenoid that hit when he fell off. He'd go, and then it would hit you'd hear the solenoid hit, and it sounded like he hit something in the ground, So yes, and my work within a relatively short period of time, I was flown out as a technical representative to convince Parker Brothers that we could do the game, even though Parker Brothers couldn't and Atari couldn't. It was kind of a interesting. I wasn't at Western Technologies all that long before I became the representative, and I had the interesting experience where we had management fly out as well, and they talked about, how we would potentially proceed. And Parker Brothers was intimately already familiar with the Atari 2600 because they were releasing games under their name. And they said, no, we need to know how it's going to be done. You're speaking in generalities, so I had to give them, this is where you either do your disclosure and get the job, or you don't, or you be secretive, and there's a balancing act there. So I had to give them enough information to convince them that, in fact, I was going to be doing something different. And we walked back with the contract for the 2600. Why that was so important is that then the Qbert contract was awarded for all the platforms, which at that time was the Atari 400, the 800, the ColecoVision, the I don't know if we did it for the Intellivision, but the ColecoVision and 400, all of those were awarded to that company. And because of my work, also what happened is Gottlieb Electronics made pinball machines. They were bought by Coca-Cola and became Milestar Electronics, and they did the early Laserdisc games where you had a background that was very, very high quality rather than computer-based, it was video. Right. And then you used some of the audio tracks to synchronize data of the sprites that went over so you could do collision detection and stuff. So they awarded, I started working on a game that was not released called Qbert Circus. And that contract came in because of my work with the 2600. So you see how this all has this snowball effect in a good way. And it led to me learning how to program arcade machines and laser interface to laserdisc systems. And I developed some of my own some of my own development equipment because I knew how to build hardware. And I'd walk in, and Milestar walked in and said, "This is not one of our,"
Yeah.
So, and the only reason those games were not released is that the video game industry collapsed. And the company that I started at, Western Technologies, when there was 13, 15 people and had grown to 65 or 8 people, I was never fired ever, and I was laid off once. And so there were 8 people left, and I was laid off, and I believe that of those 7, most of those were family members, but yeah, that's...
So it was kind of in the port of Q*bert for the Atari. It sounds like it was just this kind of combination that you had been intending, like a deep knowledge of the hardware, so that you could do all this tricky programming to take advantage of the timings and the cycles and make it very exact and fit it in there. So did you, and was that, I imagine that game was a market success, that
Yes.
port. Yeah.
Oh, yeah. In fact, it was such a success that they never really wanted to publish the numbers. It was the first time also I got a whopping penny a cartridge, up to a limit, but it allowed for about a $40,000 down payment on my first home that my wife and myself bought. And I got calls from Atari, and I got calls from later what would be Sega America, and I thought, I'm all set. I'm going to be getting royalties, and but the industry collapsed. So at that time, how could you have anything better than setting out to learn software? And it happens to be on a very, very successful, it was Game of the Year for the cartridge industry in '83 and '84, and received large recognition. Here's something else that has come to mind that's very, very important. At the time of the success of Q*bert, and we're talking, 15 million cartridges or something, which is huge in that industry. I don't know the exact numbers, but I have rough ideas. And what happened is they said, "David, this is it. This is your career-defining moment. You're not going to, this doesn't happen, but very rarely in anybody's lifetime. And you've had this, so, just, enjoy this because it's not going to happen again." If I believed that for a moment, I would have never continued. And one of the things that I forgot to mention is that one of the reasons I was able to walk in off the street, so to speak, and talk about a computerized test set at Digital Development Corporation is those individuals, highly talented, they fell in love with something. And when you fall in love with something, you hold on to it too tight. And they had gotten their degrees in the 60s and early 70s. And they did a great hard drive. And there was some really unique technology, but they were holding on to it so tight that they weren't exposing themselves to new things. And so I was able to walk in, and during the interview, or during me presenting the idea, I presented a block diagram. And so the president was in front of me. The test department, which I was part of, was to my left, and there were some engineers from the engineering department and development. He goes, "Well, David, you're going to measure voltage, right?" And I said, "Yeah." He goes, "Well, where's the A to D converter, analog to digital converter?" And he goes, "Are you doing dual slope, or are you doing dual slope or single integrated? All these things." And you used to build analog to digital converters discretely. And see, he had been prepared by the engineer. They didn't believe my block diagram. They had held on to what they had done so tightly they were not aware of a chip, and on the block diagram it said DVM. And I said, well, you know that chip that says DVM? I had to be very cautious, of course. I didn't want to be rude, but I said, but that's a digital voltmeter. So all of that's just part of that chip, and it costs $8.50. And there were a lot of surprised. So I did make a conscious decision to try not to fall in love with something so much that I could not let go of it. And so that happened with Hubert. I had to say, well, that was nice. What's next? And that's a conscious effort.
And unfortunately, there's this, sort of legendary industry downturn in the home computer game market at the time, so that the Western digital or Western technologies, shrinks greatly. What was your thinking at the time? What did you do? What were you thinking of making of that situation?
Yeah, no, here's something else interesting. Creative types as well as engineering types try to plan, I'll speak for myself. We try to plan things out. So I had gotten married and, I had this all timed. So we're getting married and then we have this down payment, we're gonna buy this house, and a year later, my son Mark, we didn't know at the time, but January, right? So November, I get laid off in November, a week before Thanksgiving. Nobody hires November, December, January, the budgets come in. So I had it all planned out. And then all of a sudden I'm sitting there with a house payment, a child on the way, which I had lost my medical, and no job for the first time in my life since the age of 13 or 14. So that's where I took the work with Kaiser hospitals for a short period of time, and me and Kaiser, it was not a good fit. To try to get new technology into a large established hospital, they're wonderful, but it's a difficult proposition,
and probably an inherent and maybe desirable conservatism. When you're in a clinical medicine context. To new things in a certain sense. So I can see how there could be a tension.
You're 100% spot on, because what happened is I set up a new lab. They had built. I moved from LA to Walnut Center, which was a new building in Pasadena, and I set up the lab there. I left before the equipment showed up for the lab, because what happened is, it being a hospital system, they had to take a logic analyzer or an oscilloscope, which would never be in the hospital, but they had a policy. It had to be inspected and tested for ground. It was disassembled and looked at. You would a piece of medical equipment in case by accident it ended up somewhere in the hospital somewhere. So we're talking about, it took a year and a half to get the equipment to start doing the work. So, you're just absolutely correct. So, what's interesting is that time at Kaiser, you grit your teeth, you do what you have to do to provide for your family. That was very much that.
Right.
I always have tried to stay. You're talking to a person that didn't have a choice and got drafted. You're talking to a person that just would have given anything to go to college, and I didn't get to do that. How do I do that? I look for the future. I try to stay as optimistic as possible. I remember my enthusiasm and my excitement about what I enjoy doing, and then I have this huge advantage of, for the most part in my life, getting to do exactly what I love doing. It doesn't get better than that. And while I was at Kaiser, that's when the call came from someone that knew me at Western Technologies, that was now a manager at Mattel, and said, David, we would like to invite you to join the Mattel think tank, New Business Concepts. You do not apply for that job. Most of those jobs are filled from the inside for people that have been at Mattel Toys 15, 16, 17 years. And here I get a call out of the clear blue sky to release me from my Kaiser responsibilities. And as far as jobs go, Western Technologies and now Mattel Toys were the most wonderful opportunities that I had in my experience. And I stayed at Mattel for over 4 years. And the group was amazing. It was set up by a woman named Susanna Rosenthal. The group consisted of 15 to 18 individuals. I worked with a doll maker that had made Chatty Cathy and all of these historic toys. He was from Lithuania, and a illustrator and mechanical engineers, and so I was the electronics guy, and all of these varied disciplines. And the group reformed itself, which is quite brilliant, based on, it's like the boys group would say, hey, we want to do something for race cars, you know? And so I would work on their project and help them with electronics. If I presented a concept that needed mechanics, I would try to get one of the mechanics teams or an illustrator or a sculptor or a mechanic, whatever, to join and work with me for a while. So it was very dynamic, and it was regrouping itself and reforming itself. And it was very, 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 very creative and a wonderful opportunity. Now, another example of going the extra mile. One of the things that happened at that time at Mattel is electronics was not doing Intel had shut down, and that division had been shut down when the video and game industry collapsed at Intellivision. Ironically enough, I had applied to Intellivision around the same time. It was one of the places the headhunter had me interview, as well as Western Technologies, and they said, no, David, you just don't have the experience. Wasn't that dodging a bullet?
Yes,
I would have been.
absolutely.
So the whole timing of this and this Mattel Toys think tank. So here's what I was going to talk about. Electronics was not getting through. The Intellivision had just shut down that much earlier. Electronics was still not like the favorite word around Mattel. But what I learned is there's a costing department, and you talk about costing within at least 1/10 of a cent when you do production. When you do production at a toy company, you're gonna make at least $250,000 to $500,000 of something. And if it's successful, more. So every fraction of a cent becomes critical. So electronics products were always costing too high and not getting through the system. So instead of taking a lunch, what I did was, I would go hang out in costing and get information from costing and talk to costing and learn about costing. I started doing my own costing, and I used their sheets, and they were going like, you know, where'd you get this from? By doing my own costing, I started getting electronic products through the system. And because of that experience, I was able to go in ultimately with Furby, and I did all the costing, and I knew where to get the parts, and I knew where to do sourcing, and I knew who to get down, and how much it costs for assembly in Asia. Like you pay a percentage, or you pay a penny a part at that time, how much it costs to drill a hole, and what boards, and whether they're stamped or whether I knew all of that from the costing experience at Mattel. So again.
Could you talk about Mattel's place in that industry? I mean, it certainly, you know, is a name that I know, and I'm sure that I have, you know, as a younger person, used many of their products. But could you talk about their place in the industry? You know,
as far as a computer industry,
or no, in the whatever you would call it, the games and toys industry, or I'm ignorant of the correct phrasing.
Okay. So in consumer electronics, Mattel, now see, this has all changed because of video games and technology and cell phones and all that. Toys are not selling quite as well as they were in times past. But at this time, Mattel, now I was isolated from Mattel by being in this think tank.
Right.
And so we did think quite a bit differently. And in fact, new business concepts, not only was it to develop toy products, but it was thinking of new ways for Mattel to do business, and we did that as well. And one of the ideas that came up is that there were a lot of names that Mattel held, like Wizard Tops or just things that were popular and famous names. And so, but if you don't make a certain number of them, we're not going to do that. We have to make 250,000 or 500,000. So why don't you license that name to somebody, or yo-yos, or like Duncan or whatever the yo-yo brand names they had. Why don't you license that to somebody else, let them make that, collect some royalties. So that's a new way of doing business. So that was also what would happen in new business concepts. Mattel Toys, now in particular, new business concepts, it was a precarious thing because Susanna, the head of that department, was very, very smart, and we didn't report directly to marketing. When you have a new concept, and by the way, in hindsight, I could see ideas that we worked on that were 7 to 10 years ahead of time. It's hard to market something when you don't know anything. It's just that new.
Right.
Ultimately, new business concepts had successes and failures because of that odd thing of coming up with things a little bit too early. But we reported directly to the chairman of the board and the board directors, and then rather than through marketing, and at that time it was John Ammerman. But Mattel has tried to straddle this. See, they had Intellivision to do the video games, and they had, they have this huge doll market does good for them, and soft goods, what's called soft goods, does well. The plush and the the doll things, and then you've got. And then to modernize, they tried to, they tried putting electronics and things. So for example, CNC, the old corded device that talked. Well, I developed the first new electronic version of that. But interestingly enough, they didn't release it at the time. They said, the corded one's doing fine. But we're prepared for if we have competition or we see signs that it needs to be replaced, we have this electronic ones developed. Well, little did I know at the time that I was developing a product that wouldn't be put on the market right away. There's just, it was a wonderful experience, and there's a lot of different things about that.
Did you see in the projects that you were doing for Mattel, did you see a growing importance for microprocessors and software? A kind of
thank you.
Like in the example we just spoke about, was that like a big trend?
You're absolutely. Thank you for that. That is a very a good question, and right on. Yes. This will give you some examples. During the time I was there was a doll called Heather, which was one of the first electronic dolls. And I did see technology becoming integrated with toys. And one of the things that I did is, this is where you play little tricks in knowing about production costs and what chips cost. There's something called a digital signal processor, which is a DSP chip, and this one in particular is made by TI, and they were very, very expensive at the time. You couldn't put them in a toy product. But in speech, if a bit of data is corrupted, you won't, unless it's more than, depending on the clock rate of you're clocking out the data, you wouldn't hear anything. So I came up with this idea of buying defective, I shouldn't say defective, but a DSP chip that would not test to normal specifications, would be fine for speech synthesis. So we were able to acquire the not premium DSP chips at a much lower cost, which led to them being able to be put into a toy product. That is the creative way that we had to work at that time to get electronics into products. We were working on visual VR using a Polymus device in 3D, and we were in 85, 86. I was working on, it's interesting, it was a small 4-rotor helicopter that had styrofoam blades, and what I was trying to do is create the electronics to make it easy to fly for beginners, and then lower the what the electronics did to fix mistakes until you could fly the plane, the helicopter, if you really knew what you were doing. We never heard something called a drone with four. I know, and this is like in 1988, 89. And so how far, and so it's interesting. It went to the focus group, and the blades were made out of styrofoam so that if they broke, it wouldn't hit something, it wouldn't damage, and you could replace them. The reason it had trouble with the focus group is that the parents still saw it as the toy got broken, even though it only cost like 98 cents to buy blades for it. But there's something that I learned at Mattel. There's a whole lot of things I learned at Mattel, but one thing in particular I remember. So focus group is where you have, there was a large room full of toys, some new toys and some more like tea sets and building blocks and just a variety of things. And you would see, and it was all filmed, and there were two-way mirrors, and the parents would be invited sometimes to play, and sometimes the children played by them, alone. And we would present them with various things and see what the reactions were. Well, Heather was presented to a very bright 9-year-old girl. And so she sat Heather down across from the tea set and says, "We're going to have tea now." Young women like to do this tea. And Heather kept interrupting the girl's play pattern. What she wanted to do is like, "I'm hungry, let's eat now," or whatever it was. It was just interrupting. And I watched that, and I'm going, oh, I don't like that. I don't even like the feel of it interrupting the play. So why I said a bright 9-year-old is she took the batteries out of Heather and sat Heather down and went, "We're going to have tea now." So later when it came to Furby, I said, I do not want to do anything that interrupts the play imagination of a child. And that's why I developed a Furby language. And the Furby language was developed, and it was really a language. It follows a format, it follows lots of details of a language. And by some it's been classified officially as a language. But for the younger children, they'd say, "Hey, let's have tea," and "Oh, del utai, unai, bube welo," or whatever. And so the child would say, "Okay, you wanted black Earl tea?" Right? But for the older children, they would learn it was a language. And ultimately, I was interviewed at a period of time later, and they said, "You've got children that are talking back and forth to each other, kind of like Pig Latin. They've learned Furbish, and the parents don't understand what you're saying. What do you think about that?" I said, "What could be better?" But that was, the purpose of that was not to interrupt the wonderful, vivid imagination of Furby. As a hobby, I studied magic for a while. I was under a professional magician. And what I learned about, and I did that for a reason, when you're making a toy product that you want to see make alive, you do things that are a magic act. In other words, you play with perception, and you let, inside our brain, there's something some people refer to as inference engine. In other words, the brain doesn't like missing information or data, and so it fills in. A perfect example is, I know my wife very well, Cindy, and I could see her walking over on the sidewalk away from us, and by the way she walks and whatever, I'd say, "Yeah, that's Cindy," and I can see her face. Well, there's no way that my vision really does see her face, but my brain is filling in missing information. We've had that experience. We walk up to someone that we think is, and we go, "Well, hi, Sue," or whatever, and they go, "Oh, you're not Sue." Well, our brain filled in the missing information and made us think that, So I allow specific missing information to be filled in by the user that interacts with the Furby toy. And it's very much a magic act. So it was so magic, in fact, that NSA banned Furby for initially being able to learn and learn and repeat secrets. But later they said, well, maybe we're worried it might be transmitting something. Or if they were to have talked to me at all, it had 256 bytes of RAM. It had ROM. It had nothing that could, could have done this recording and reporting and transmitting. The other thing is the Furby language also allowed for the development of the toy to evolve and seem more lifelike. If you interacted with the toy and more often than someone else, it started intermixing Furbish and English until it spoke more English. So it gave this evolutionary process to the toy. And interestingly enough, nothing goes to waste. The Furby language is made up of some kind of little jokes, like sleep is called Wei-lo, but Thai language, Japanese language, a little bit of Hebrew. Elo comes from the word Elohim, and Elo means light to Furby, bright or light. Chinese, I won't say it correctly, but Da. So when Furby says something like Da Elo Utai, Da, Chinese, big. Elo from Hebrew, Elohim means light, and Utai means up, big light up. That means good morning or good day or something like that. But anyway, that was all developed not to interrupt the imaginations of children.
Will you forgive my ignorance about it, but with I guess, how Furby operated, I hate to...
No, it's fine.
Which is that its response was, it wasn't doing any form of speech recognition. It was just, hearing that there was a sound coming, and then it would, play some response, or maybe you could explain it to me.
No. So here was the trick. I have a sensor that recognizes light and dark.
Okay.
I happen to pick a cadmium sulfide cell because it has the same kind of sensitivity to spectrum that our eyes do. And there's something else called hysteresis. In other words, it changes over a period of time. So it could slowly adjust. It was very, very critical that it's all relevant. See, we think in gray. We don't think yes, no, binary. So there's a simple weighing system inside of Furby, which some people have classified as AI. So put a light sensor, it can know. So if we were in a bright light, we could tell if it got somewhat brighter or somewhat darker. Or if we were in a dimmer light, like a bedroom, night light, it would adjust to that level, consider that normal, and it'd still be able to say brighter or dimmer. There was a sensor in the back, it knew if it rubbed your touched the back. There was a sensor in the tummy area, it knew if you touched the tummy. It had a very simple ball mechanism that allowed if you could tell if it tipped side to side or if you held it upside down. And a sound detector that would go to the ambient level of the sound, and it did basically could tell if there was a loud sound, and if the loud sound repeated within a certain time period, and you would say that must be a rhythm, it could detect the beat of a song and start dancing. Okay. So by gathering sensor data and combining it together in a way, we present the illusion that the creature is alive. So when you rub its back, it purrs. And another trick to the programming is that there was something that was developed by Maslow that talks about this pyramid. I didn't do an exact, within the world of the creature, I created something that if it was hungry, it didn't care as much if you rubbed the back or if you tickle. So by just putting the programming in a specific order, it developed the level of needs or how things worked for free. I didn't have to write the code for that, just by saying, oh, if it's sick, it's not going to do anything else other than be sick. Oh, and there was an infrared beam so they could talk back and forth. My son Mark was 12 at the time, and our family was very much involved in the process, as were some of the neighborhood kids. And I said, there's a rule. Furby cannot do anything that looks dumb. And like, I didn't give it hands because if you had food and it couldn't reach out and grab the food, it would look dumb. And it didn't have legs because if it gets stuck under the kitchen table or in a corner, it would look dumb. So Mark at 12 went, well, okay, Dad, you got a bunch of Furbies in the room. Yeah. Okay, what do they do? Well, you rub them the back, they purr, and you tickle their tummy and they laugh, and you hold them. No. Does one Furby know that another Furby's in the room? And I go, no. He goes, Dad, that's dumb. So my 12-year-old gave me the idea of adding two-way communications where they could talk back and forth to each other. The other thing that it did is if one's sick and it sneezes, it gives the other the cold through the IR transmission. So, and then there's a little known disease, I've forgotten the name of it, or an affliction, where there's a sudden light change and they sneeze. And you can look it up on probably Google. But I put that in there. But here's how it was interpreted. There was someone that let me know that they were dusting and housekeeping, and they said, "Oh, I'm sorry. Furby started sneezing because I got dust in his nose," you know. But it was the light change from the dusting. So people started, you know.
Again, it's that inference machine aspect to it.
So you call on that. And so those sensors, the more sensors, the better. And they can be very, very simple. And the most difficult, here's another little interesting point, was that there's a lot of outside stories about how Furby was developed and how long it took and all these other things. And I can tell you that the real code for Furby started after Toy Fair. And started in February, and it was released in July. So we're talking five months, yes. And so I had to do a table-driven implementation, which means I could change things very quickly.
Right.
Things were looking very well, but it was very, very nice that it was left alone. That ultimately allowed me to succeed. Tiger was very busy with their own in-house development and things for Toy Fair. It was a big rush, and after they had their products. So I was left alone because, to be very honest, what happened is I had all of these things working, but it didn't seem like a life form. And so if somebody would have come to me and said, "Okay, Dave, show me what you got," like a month ahead of time, even like 4 weeks ahead of time, it would have looked like a big failure. But what happened is I was able to adjust, like a joke or like a magic act. The sequence, the timing, all lends credibility. So I was able to quickly adjust all the, like how long it responded after a touch and how long it took to go through the verbiage and so on and so forth. It made it seem more alive. Another trick that I did, and I talked about it a little bit with the Universal Studios, but I did some movie special effects work early in my career doing animatronics with movie creatures. And I met a group of people called puppeteers. And puppeteers walked around with socks on their hand, or puppets, and they'd say, okay, should you say like, "Hi"? If you just say, "Hi, how are you?" that's different than, "Hi, how are you?"
Right.
And so the idea occurred to me, because most electronic toys, both before this time and after, it's like "Hi, how are you?" and it's mouthed in. I hired a group of puppeteers. I created a program where the puppeteers moved their joysticks on typically a Futaba transmitter or a joystick, and they created the database. So there were several tricks about that. One is it made a more accurate tracking, and it added more emotion. When it was more emotional, the mouth could open, and the ears added to the emotion. And so they did what they thought as puppeteers should be done. But there was another little scheme behind this, and that is, instead of me writing all that programming, I wrote a program that collected the data from their movements and created a database structure that ultimately went into Furby. So it sped up the process time. I had 5 months, and so puppeteers were, and it also led to something else. The worst thing that could happen is you ship a couple 100,000 of something that would be a breakthrough toy and it breaks. And the word gets out real quick and you kill the project. So I had models built that were being used for puppeteering initially 10, 12 hours a day, and ultimately, because we did foreign languages, we did Furby Baby, it turned into 24 hours a day. But for the Furby project, we had models and they were operating, and I could see if they were going to hold up and what was going to, And the motor, all of this mechanism was driven from one motor. That's one of the patents that I hold. And the Futaba motor is not supposed to go backwards and forwards the way that it does. And because it had a carbon brush, I apologize, copper brushes instead of carbon brushes. If you want to go backwards and forwards, typically you would have carbon brushes, but they dropped the voltage too low. This product had to operate off of batteries. So Futaba said, you can't use, they heard what I was doing, they said, you can't use this motor for this, and the project was in dire, it might be canceled. So I just went to the people that trusted me and said, hey, look, we've been running these models for 24 hours a day now for 2 months, and we've not had a failure in the motor, so I don't think we have to worry about it. So we went forward with it, and I would have never been able to do that. So I was testing the models, having the puppeteers basically write my database structure for me, and there's a lot of thought that goes into, and the thought came from experience with production, experience with costing, experience with hardware, experience with software. I did a Geo Safari Talking Globe, so high quality linear predictive coding. In my resume, I incorrectly stated 80 bytes per second. It's actually 80 bits per second of speech. So all of those things tied together.
Well, let me take you, that is fascinating, but I want to take you back into the chronology a little bit to get you to the genesis of your work on Furby. And it struck me that you were having, you're in the Mattel organization, and it seemed to me that it sounds like that you created your own design studio or your own firm, Sounds Amazing Design, kind of at the end of your time with Mattel. Could you talk about that transition or
Yes.
how that worked?
Yes.
Yeah.
Combinations of things. Mattel was a wonderful opportunity, and like I said earlier, one of the best jobs that I had. But when you have children, you start thinking about where am I going to raise children? Where am I going to have my children schooled and all that? So thoughts started turning to leaving the Anaheim, LA area for our children. And so Mark was about, Cindy's oldest son was already living with a father at this time. Mark was about ready to start kindergarten. So that was part of what was happening. And so Cindy and I were both on board with me starting my own business. Part of it was the point that other than Mattel, I worked at places for a year and a half. The other thing that interestingly happened is that I had just, salary-wise, I was just making way more money than I would have had to step backwards into a typical electronics job and would have got paid less money and would have been bored. So it was a creative way of, I loved Mattel toys in the think tank. A job is never, you don't never get to do exactly what you want to do at a job. So I just kind of had this idea of maybe creating a better place to live for my family, my just starting family, as well as me getting to be a little bit more picking and choosing about what I worked on and getting to choose more about things that I was interested in. And when you're interested in them, I could do a much better job than if I was, and now there's always a reality with me. I've been very grounded because I've really had to convince others of my capabilities, and I've had to prove and do all of this on my own, and with my wife and family support. And I don't belittle that for a minute. It would have never happened without Cindy around. But it's not like I just said, oh, I'm going to start my own business and took off for the wilderness. In fact, we did move outside of Grass Valley and live off-grid for a decade when I started my own business. Unintended consequences, and if I don't remember, it's really wonderful, and it was great. It worked. But, so what I did was I started working at home. Something I don't talk about much is I did not have the traditional contract with Mattel where everything that you do 24 hours a day is owned by them. I had stuff that was on record, and I was interested in doing things, and the new part of me working there was that I still had my own work. Okay. And I was not going to compete with them in toys. One of the things I firmly believe in is ethics is something very, very important, and so I honored that commitment. I did not work in toys until years later, and I was released from that year period of time or whatever of not competing in toys. But what I did do is I started working in the evening. And I started working with Universal Studios doing movie special effects stuff. And I did an RF controlled, there's something called walk-arounds where people would put on a costume and they walk around. And I developed a transmitter receiver battery pack system that transmits data from a tape, a magnetic tape at that time, that transmitted the signal, and they were on stage and their walk-arounds, and the eyes and eyebrows and the mouth all synchronized. And I was doing that kind of work and still working at Mattel, so I was working 2 full-time jobs because I wanted to develop a client base to then do a transition to my own business. Right. And interestingly enough, Mattel broke its own policy in allowing me to continue to work with Mattel. It never really materialized in the way we thought, because I was working on that 4-rotor helicopter thing that we would now call a drone. And because we reported directly to the board of directors, I did a demonstration flight where I flew it right down the board of directors table and blew the papers off in their laps, and then I hovered it up to the ceiling, and then brought it down, and I flew it right over and landed in front of Susanna Rosenthal, the director of the department. And they were all just, oh my God, we have to have this, we have to have. Well, as you know, David's going to be leaving us, and we don't care, we have to have it. So they waived their own, And that's a whole long story in itself, but you get the idea.
Okay, so you kind of took your job with you in essence, developed a few other clients, and then brought that project from Mattel with you.
I never was able to finish that with them, but I was building clients to work, and then I moved to, and I did start. Initially, Sounds Amazing. That name came from, as I developed products through my career, the Talking Globe or the other, well, that was later, but as I developed products, people would say, David, if you can do that, that sounds great. That sounds amazing. So now for the more creative firms, I could say sounds amazing. But for the more engineering firms, because I later did HVAC controllers, heating and air conditioning, and I did some more interesting, but not quite as, but interesting enough. I had to have sounds amazing design. They like that better. So.
And forgive me, where was it that you then moved to? You moved out of the area to Grass Valley?
Grass Valley, Nevada City area, which is outside of Sacramento.
Yeah.
Yes, and we moved 45 minutes outside of Nevada City. We were in Nevada City on their Nevada land, but it was 45 minutes from town. Off the grid, generator for power, wood for heat. We lived that way for a decade. It was a Bavarian farmhouse. And there's pictures of Furby and the creation of Furby in that lab that was in that house. There's some other important things that happened during starting the business. My wife and myself never had credit card debt. We would wait for something and pay for it in cash. We started the business by buying a home in Anaheim at like 128 and selling it at 242, and we had paid down the principal even quicker than we were supposed to. We walked away $144,000 in 1989 and put half down on a new house. The payments were low, and used the money to start the business and never took a loan or anything. So the confidence of my wife and led to all of this. So
How were you doing that work so remotely? Well, maybe you could explain.
No, go ahead, yeah.
Yeah, I was just curious about your work process and how you manage that.
Yes, so we picked a place where the school was, number one, the school was great for the boys. It was a very small school. It was really back to the golden age of education where first grade, second grade was in one room and third grade, fourth grade was in another room, and there was a teacher and teacher's aide in each one of those, two teachers' aides. It was for the forestry department service, and so we happened to be able to participate in that for our children's education. We made sure that FedEx came to our location, even 45 minutes out of town. So in large part, I would order parts through catalogs. The internet was just starting. And my wife would drive things back and forth to town. Now here was the unintended consequence that it just really helped. So I was working with Universal Studios, and they said, Dave, we need some more units. We were only going to do this for 6 months, but now they ran it for like 7 years or something, and my stuff wasn't designed to, and they beat it up and they drop it. So Universal Studios would drive up and they went, David, this is gorgeous. You're in the middle of the Tahoe National Forest? Some people would call before they got there and goes, are you sure we haven't passed the place yet? And here's what happened. The rumor started going around that this guy lives out in the middle of the woods. He must really be good. And it was a self-fulfilling prophecy. And they would come out and do camping and a little vacation. Well, we'll do some fishing or camping or whatever while we're waiting for the, and we'll take it back with us. And so people I had people in the Bay Area, in electronics in Silicon Valley going, David, when work was tough, work's kind of thin. What are you doing? Where's your ads? What do you do? It's all word of mouth. Can you send me some of the, And later in my career, even before Furby, I started. It was very difficult. It's a balancing act between taking enough work. So many stories there. One of the things that happened is I learned early on that if I have one or two large clients and one of them goes bankrupt, it almost put me out of business because they owed me in 1991 $36,000. And it was 6 months worth of work from one of the clients. So don't put all my eggs in one basket was one of the things I learned. But there were so many and the logistics of living out there, was interesting. We had to use wood for heat and chop wood and all of that kind of stuff. But it was a very, very exciting time. And I got to do, for the most part, what I want. Early on, I took more projects that were not exactly, but later, it became so successful. I had people a little upset with me because I would say, okay, oh, by the way, see, again, mind racing. I got to see what new products failed, what succeeded, why they failed, why they succeeded, and somebody else was paying for me to learn all of this. That's why I could do Furby years later. And so what happened is, sometimes it'd be a great product, but no marketing and no distribution. Sometimes it was great marketing, great distribution, and no product. Sometimes they didn't understand the true cost of doing the tooling or injection molding, and so I had become familiar with what it cost to do injection molding and tooling and a mold, and the time involved and production stuff. And so sometimes they had enough money to do the electronics engineering, but no money to do all the tooling for injection molding. And I watched, and eventually, and I had. And really, in the world of new concepts, and like Mattel toys, if you develop, let's say you come up with 100 new ideas a year, and by the way, I would come up with maybe 8 to 10 new ideas a month. If you made 1 or 2 to market, you were considered brilliant. Right. That's statistically where we're sitting at. And so later in my career, people would come to me and they'd say, well, I said, I'm not available now. Dave, it's fine. We'll wait to word of mouth and reputation. It was just unbelievable.
Would you characterize it? I know you said you did a few different things that were more on the, like the HVAC engineering thing. But would you say that the majority of the work that you were doing was in toys and games, or how would you mainly classify what these projects were?
No, whenever possible, I tried to do projects with the most flexibility of creativity. For example, I did a product for Educational Insights called Geo Safari Talking Globe in the 92, 93, somewhere. They still make it to this day. What's interesting is they came to me without that in mind. They're a very, it was two brothers owned a company. I don't know, they're still around. I haven't, I don't know who owns it now or if the brothers still own it. And they said, because of reputation, they came to me and said, we want to do an educational product. I said, okay. We wanted to use CDs. Okay. How much is this product going to cost? $400. I said, $400? Who's going to buy this? Oh, the school systems will buy it. And I said, well, do you know about speech quality and the cost of speech per second? Well, no, we want CD quality. I said, well, what if it doesn't take CD quality? Well, we could talk about that. So I went down with a presentation, and typically it would be a table full of people. And so I presented CD quality speech and different technologies, each using a lower, you shouldn't call it lower quality, but a lower data rate. Mm-hmm. And there was, in that the lowest was LPC, and then there was, just normal PCM and all the various ways of encoding. It eludes me all the technologies that were available in '93, but I demonstrated each one of those. And it got down to LBC, which I had developed because of CNC at Mattel. I was exposed to LPC speech and developing of that and recording of that and worked with some Disney characters, Mickey Mouse and all. So because of that experience, I had been doing LPC speech and some of the other products, which is 80 bits per second. And they said, well, that sounds fine. So I went, okay, we don't need CD. You don't have to have $400 product. And ultimately, because of my background in gaming, it turned more into a game. And it ended up retailing for $99. So, and that had all kinds of tricks in it, but it was LPC encoding. And so those were the products that I wanted to work on. They offered me, I would be able to contribute the most. I mean, I did some innovative things and homes, some HVAC controllers that were considered homes of the future. You can only go so far with heating and air conditioning. Mm-hmm. So yes, whenever possible, games, toys, those type of things. Movie special effects, movie stuff, and
and sort of the things you were doing with the movie studio, as you described before. So kind of in the consumer electronics and entertainment nexus.
That's correct. And that there was a company in Grass Valley that had a contract with Neil Young. It was the singer Neil Young, and he had bought a portion of Lionel Trains. And they were trying to develop a technology to control model trains. And so I'm the one that, I'm on the patent, Neil Young and myself, developed a new concept, which was an electromagnetic field. A train is a model train, drives on a track. Right. There's a brush that picks up AC that powers the train. And again, I had learned because of my earlier experience with the Tesla coil and the spark gap transmitter, when you have a little AC motor trying to get powered off a track and it's jumping, the brush is jumping and making sparks, that's transmitting on all frequencies, and it causes a lot of noise issues. And so everybody traditionally was trying to send data through the area where you're, have a spark gap transmitter and all this RF noise.
Right by the noisemaker.
And yes, and infrared doesn't work because as soon as you go into a tunnel, which is really popular on the model train sets, you lose control. I don't know exactly how to explain the process, but by the way, sometimes it's better that I don't know how many people have worked on it and haven't come up with a solution. It's always better that I don't know those things. So I was just sitting up in a group of people had come in to visit me to talk about potentially what would I do if I was working on model trains. And I think that all of the information you gather is there available at a subliminal level initially. And I just knew, it's the oddest experience. You just go, I know what I can do. So instead of sending signal through the track, we'll send the data around the track. You know, what does that mean? I said, don't worry, I'll do it. I'll be able to do that. It's something that is at an intuitive level, a gut level. It's and I didn't know what it was at the time, but then I had to think about it, and then I could coax it out, so to speak. And that.
So you saw the kind of highest level design solution, you know, around rather than through, and then figure out what around means.
Yes.
Yeah.
And so just like Furby, I saw within what's reasonable what it looked like, and you visualize and you think about what it does when you pick it up, and so I start at it's done, then I figure out how to get there. And so that's been very much the way for me, especially in my later career. Mattel Toys contributed a lot to the whole brainstorm thing. They brought in experts in brainstorming, so I was able to learn from that process. And some of the key things were, don't stop an idea before it matures. And what I mean by that is it's like, let's say I'm going to develop anything, a new doll. And you'd say, well, the doll should be this tall, and it should be, no, we don't need to talk about that yet. And then there's something else that combines with it. Whether left brain, right brain is a true definition of something, it's easy to explain it in this fashion. Yeah. When I do production, when I do test engineering, when I set up, do costing, and I do known things, the temperature of solder, the temperature of a molding machine, and when plastic melt, all that, those are known. That is very much left brain. It's limited, it's known, it's math, it's that. When it's right brain, it's very much more like painting. It's very much more like unlimited. It's almost dreamlike. It's almost not physically present. It's more without form, and so those feel very different, dreamlike and fact, you know. And so whether that really exists or not, I've learned how to switch that on and off in good portion because of my experience in Mattel Toys. And so when you're brainstorming, the tech part of me goes, you can't do that, it would cost that much. It costs too much, and you can't, and it won't run off of batteries for that long. And you silence that, every time that comes up, you just remove it. So that the process evolves into something unexpected. And the final product is beyond any initial concept as it evolves. And you cannot stop it. The other thing that's very, very important, if that you get into new product development, I've had to look at it this way. Okay, I do something, it doesn't work. Oh, I know what doesn't work. I'm going to try this. Too many people, when they do something and it doesn't work, they go, I failed. They don't take the next steps to ultimately find out what the real solution is. I mean, we hear the story about Edison in 1,000 or whatever times, how many filaments he tested, but we don't think about it or apply it in our own lives. So I've had to be very, very cautious. Furby failed hundreds of times. Really. Yeah. And even in production, there were critical times where the ears weren't moving. And they had samples ready, and everything's going to start getting released for October and Christmas, and it was critical. And there were 3 companies sitting there, Chinese, with the whole table of people, and I'm sitting in mainland China, and they said, the Furby's ears aren't moving, the Furby's ears aren't moving. We don't have time, we just won't make them move. I'm going, we can't do that. The puppeteers tied the emotion of the character with the ears. We can't remove that. And there was just panic. And the ears wouldn't move. And I had a prototype, the ears moved fine. I needed a quiet moment. And I went in the other room and I looked and I did something. It was just simply, they had not followed. Soft goods are like the fur.
Yeah.
And where it went around the ears, there's a pattern. And what happens is they weren't stitching it right, and the fur was getting stuck around. And so what I did is took some scissors, cut the fur, and took it back, and it worked. I said I had to give him a haircut, it worked, and diffused the whole situation. The same way, the infrared is very, very low cost. I couldn't afford the normal TV channel changer integrated circuit that does pulse width modulation and sends data out over a carrier. There's a carrier that carries, right. And then you turn, yes, and that's how you get infrared data. I just put out pulses because I don't need to talk much further than face to face. And then for production reasons, I made it double that. So Furby's design, the IR would only work about 12 feet, and in real life, 10 feet. 4 feet because of tolerance of, so it wasn't working. They can't talk back and forth. We told you that wouldn't work. You can't use that. You have to use pulse width modulation. Well, here's where I found what I found out. In saving time, when you do injection molding, there's a machine and you have to heat the cavities, and then you heat you heat the cavities of the mold, and then you inject the liquid into the cavities. Well, if the cavities weren't sitting long enough, part of it would be cool, and what happened is as the material hit, it would cause a ripple or a wave effect. So what I considered a lens in the front of where the IR came out, it was making the IR do this. And I found that because I had Chinese newsprint on the table, and I'm putting these lenses looking at it, and I couldn't read the Chinese underneath one of the lenses. So I said, what happened? Well, we're saving time. We're not letting the tool. So I said, you got to let the tools heat. But anyway, so Furby failed hundreds of times. So.
Well, now you mentioned that you moved, that you were 10 years in Grass Valley, and then you did, and then you moved at that time. Is that correct?
No, Grass Valley. Well, no. So, what I did was, when my oldest son got ready to go to high school, we didn't want to ride in a bus for like 3 hours a day, so we moved into town. But no, during my active years of Furby and such, that was it. And I ultimately shut down. From 97 to 2001, because of Furby and all the languages and all the Furby babies, that was my main full-time job.
Right.
And then right after that, I shut down my business.
Well, could you talk about the very genesis of the effort that would lead to Furby? You know, it sounds like you were doing projects for other clients, other companies, but this sounds like, you know, a project of your own, if you will. So
yes.
Could you just talk about your decision to do that and how you came to the general idea?
Yes. Necessity is the mother of invention. And what was happening is, I was at the point in my career where I was turning down 10 to 12 projects a month. Everything was going well, but the income was great. But I don't know about other small businesses. But I don't know. So I had a son that needed jaw surgery, and it was to the tune of about $100,000 to $110,000. And I don't know about other small businesses, but I didn't have like an extra $100,000 laying around in the bank. But what I did have is a year and a half or 2 years worth of expenses in the bank. So I talked with my wife, and I said, the only way and we tried getting help, we couldn't get help anywhere. And there are different places that said, no, we only do from the neck down, and no, this is considered pre-existing, and we no, and no insurance and none of that. So Cindy and I sat down and talked with each other and said, how are we going to take care of this? And I said, the only place I know that I could get enough money is that I'm known in the toy industry, and if I could come up with an idea with a toy that would create a royalty, they would run a minimum of 300,000 to 500,000. And if I could get somewhere between, typically in the toy industry, you get, in those days, you'd get 5%. But if I get somewhere between not a Lucas and not a Disney, they get higher. And that's 5% of the wholesale manufacturing, the cost, the company's cost, not the retail. If I could get 50 cents, 75 cents, whatever, and they'll run a minimum of 250 to 300,000 units, maybe 500,000 units. We could pay for this and maybe pay down the house some more. Maybe if we got a couple $100,000. Because we didn't have debt and because we had enough money in the bank, I shut my business down. And I talked to Cindy. I said, okay, look, we got about a year and a half worth of money. So if I can't come up with something in the next 6 to 8 months, I'll shut my business down. I'll work on this full time, do what I need to do. If I don't end up with something, I'll ramp the business up, start the business again. And yeah, this is what happened. And so, because of other people, watching other people develop their products, I learned, don't stick a whole bunch of time in this and don't stick a whole bunch of money in it. And so I talked with a mechanical engineer about helping with here's what happened. I need to backtrack. Okay, well, where do I come up with a new idea? I was known in the toy industry, so I could get in the door of the toy fair, which is closed to anybody but professionals in that trade. And so I went to the toy fair in New York in 1997. That would have been end of January or February of 1997. And I went through, I was there for 5 days, whatever it was, in New York in a little hotel room, going and looking at all the new products. And it's like, okay, more yo-yos, all more of this, all more of that. This is not working. Maybe, I spent the money. Well, what's going to happen next? Well, the last day of Toy Fair, I walk into a booth that was set up by Bandai, and at that time, Bandai was the Power Rangers. Right. And in there was a product that I later read about that was a huge hit in Japan. It was Tamagotchi.
Oh, yes.
I saw the little LCD display, and I picked it up, and I went, well, that's interesting. It's kind of flat. It's kind of not so personable. If I were to do something like that, I would make a 3-dimensional virtual pet. Now, see, I still get chills now, because here's what happens. Remember from my experience at New Business Concepts, I went, if I'm too far ahead, not going to work. Right. If everybody's joined the party, I'm too late. So but now, if Tamagotchi becomes a huge success, like it was in Japan, because nobody knew about Tamagotchi yet, virtual pets, the idea of virtual pets will be exposed and will have had some success. And I can piggyback on that and then launch what I was hoping would be a better virtual pet. I wanted a 3D pet that you could touch and you could feel and you could rub it and it would purr, not an LCD screen. But that's where the idea came from. And that was the last day of Toy Fair.
And the virtual pet is a really interesting framework for it, because that's kind of what the proof of concept, was there. I was wondering, I was thinking about the question I had is like, how should we properly think of your concept for Furby? And I was thinking of, is it a low-cost interactive robot? I was like, is that a way to describe it? But I mean, I think which I guess fits with the idea of a virtual pet. But it's interesting that was the inspiration, a kind of more fully articulated version of that idea of a virtual pet.
Yes, that's what led to the idea. Now, here's what's important about when I started thinking about Furby. Furby was originally a fur ball. That's where the name Furby came from. It was like a little ball of fur, and you would pet it, and it would kind of it would be like a little balloon that would change a little bit. And it would change. It would purr. I'm going like, I talked to Cindy and I talked to the kids, and it's like it looked more like a tribble. I like, oh,
that's exactly what I was going to ask.
I'm heading down the wrong path there. So, but I had to think about. Okay, so here's something else very, very important, fundamental. There are a lot of dogs and a lot of cats that don't have homes. I didn't want to displace dogs and cats. The other thing is, I couldn't make something that looked as good as everybody knows what a real dog does, and everybody knows what a real cat does, and no matter what I did, no matter how good right then, it would be not good enough for me. It wouldn't be a success. I had to create something that didn't exist, that people didn't know what it did and what it was. They didn't have a preconceived idea of what it should or shouldn't do, other than that it was alive. So I tried to create a life form, actually, and I tried to create a life form that would seem like it was a friend, and that it was evolving because of your interaction with it, and that it evolved later, with other things, not the original. Well, in some ways, the original evolved based on your interaction with it. That was the concept. I had to make it like not teeth, because teeth look scary, and make more of but not a sharp beak. To me, it should look smart, so it should look more like an owl, potentially, a little smart. But it should have fur, because that's kind of like a teddy bear. It shouldn't break the play pattern, so then furbish, and don't make it interrupt the child. It doesn't lead it. The only time it ever led anything is that if it sat long enough to almost go asleep, it would say, "I'm bored," boring, or pay attention to me, basically, to prompt the child to interact. But I never tried to guide the play. So.
In the same way that you used kind of the techniques of magic and activating people's inference engines with various aspects of Furby, was that also at play in how you began to think about making it adaptive, or how it would evolve over interaction? Was that another magic trick, or how did you create that?
Right. So things that are alive to me, just like your best friends and they evolve. They change. It's dynamic. That's part of life. And so to create the illusion, you have to have it evolve in some fashion. So the evolution of Furby, I couldn't, at the time, I didn't think about it popping out of an egg and evolving in that way. But it learns English because of you, because you spend time with it. You are a caretaker. So you bond to this because it relies on you. Now, what I didn't want to have happen is Tamagotchi. If you didn't take care of it, it died.
Yeah.
I didn't want to go that far. And the other thing is, I remember being in meetings later, and there would be an attorney who would pop out of Tamagotchi and go, "Sorry, got to feed it, so my kids at school couldn't play with these anymore, and I don't want it to die." So Furby doesn't die; it got sick. But very much. There was a whole a system of evolution, and it was shown by the vocabulary. It was also shown by how often it would do things. Now, so for example, and by the way, what's interesting is because at the time it was released, Tiger didn't know what they had, because what allowed for the success is I was left alone. What I learned at corporate Mattel is an inventor would come in with a product, and then with fully good intentions, it ended up being designed by committee, and it would change into something nobody liked anymore. So Furby succeeded in large portion because they trusted me, I developed a trust, and they left me alone enough for that to happen. So what was interesting is they had them out as they're showing them as they were released, and they're going like, I can't get him to do anything, all he's doing is sneezing and coughing. I said, well, you have to feed him. What, you have to feed him? I said, yeah, if you don't feed him, he gets sick. Now, you know who figured this out intuitively? Children. Children said this to me. If you don't feed him, he'll get sick. So I'm going to feed him, and then he won't get sick. And if he gets sick, he'll make these other Furby. They knew it intuitively, but marketing didn't know it. I said, you got to feed. What do you mean? I got to feed him? Yes, you got to sit and feed him. I don't want to sit and feed this thing. Right? So they learned to feed Furby, and then Furby would get better, and then Furby would want to play. But then Furby played for a while, and the illusion was what I was counting is motor movements. And so I knew that if the motor moved back and forth, it was this kind of movement, and I could count. So the more it talked, the more you played with it, the more it talked. And if it talked, it evolved, and the more you had the motor moving, it slowly evolved into the Furby language. It was tables that filled in. Okay. And if you didn't feed it enough, it got sick, and all it would do is complain about being sick, but it never died. And on Power Up, it randomly selected a name like Tulu or Alo, and that was the name of your. So the Furbies would have different names. And yeah, so there was something else that you had talked about, and
well, let me take you to a different question.
Okay.
You know, you have a very limited amount of time in which you need to develop what you're going to do. You get this idea, you know, did you, and within what, how many, well, the development of Furby took place over what, the next 7 months or something like that?
Okay, so I can help with that.
Yeah.
So I wanted to do something that seemed alive. I brought on a mechanical engineer to help me with mechanics. And over the next 6 weeks, we did there was a very primitive mechanics that could show that you can move, and under my direction. So in the movie special effects industry, they have cams that move. It's an old technology, and it can move eyes and mouth and all that, okay? But I had to have one motor, it would cost too much at this time. So what I had to come up with is an idea to make cams that would move forward and backwards under computer control and seem not like it was repetitive. I learned it because of puppeteers and my experience with puppeteers. So a puppeteer, this is the idea. Remember I said nothing goes unused or unutilized. When a puppet stops talking, his mouth is closed. He doesn't sit there like this. So that's neutral. So if I go from neutral and I go one direction, I can do certain movements. And if I go the other direction, I can do other movements. But if I put another neutral over here where it's closed, then I can come this way or this way on the cam, or from this point in the cam this way or this way, or from this. So I can get what appears to be random motion on one cam. So that was very much, and it was patented, and that was what was different. So the mechanics that was developed initially didn't go into the original. There was a lot of problems with the mechanics. We had somebody that was released from the original development, but so more to the point. Over about a 6 week to 8 week period of time, all we did was do a mechanics that just showed more than one movement off of a motor. And then because of my work with LPC speech and because of the globe and because of other things, I had an idea of attaching a low-cost processor, 6502 derivative, a 6507 with memory on it, and attaching it to an LPC chip so I could show that two low-cost chips, processors, in the cost range of around, for both of them, 85, 90 cents, could give us thousands of words of vocabulary. And that's all we had. And I presented the concept. The concept was presented to Worlds of Wonder, who had done Teddy Ruxpin.
Right.
And they wanted the idea, but they thought it was only for girls, and they wanted to do a whole big focus and testing that would take about 6 months. And here I am going, we can't do that. Tamagotchi's going to release. It's going to be either a big hit or it's not. We can't delay this by. I thought everybody was going to be on my heels with versions of Furby after they saw Tamagotchi. That didn't materialize that way, but I thought we got to get. So we said no, we can't wait that long. Presented it to Gibson Greeting, oddly enough. This is not known by anybody. Gibson Cards. The family was trying to revitalize it, and they were starting other departments. And he said, David, we'd love it, but we're not going to be in the position of doing anything with this for about a year. And then a friend, who ended up becoming a friend, a guy named Richard Levy, was known in the toy industry for licensing products. And so he got me introduced to Roger Schiffman of Tiger Toys and Randy Riskman. And we had a rather odd meeting. So Richard called up the people that he knew in the industry and said, you got to just see this. Oh, I'm in a hotel and wherever, and my back is killing me, and I've got, and I'm kind of all, So, but anyway, we had this interesting meeting where I went to the hotel room and, with a guy that had done the early mechanics, and we gave a presentation. And later he admitted it was like the most remarkable thing he had ever seen. So we waited for a bunch of the holidays, and then we signed a contract in like November of '97 to make a prototype by January for Toy Fair. Yeah, so that's a whole interesting story in itself. But it was a 6-8 week time of flying around. Just did the bare minimum. I spent about $1,600 at the most, because I said don't spend a lot of money.
Right.
And if no one's interested in the concept, slide it, move on to something else. So and that was Tiger Electronics, and
so then you had to have a prototype for the show, I would imagine would have to be a fairly sophisticated prototype. It's not going to be like a board, with the chips and.
Well,
it had to be.
Yeah, interestingly enough, the mechanics was in a very difficult position, and so this story has never been talked about anywhere. I was sitting in the hotel room trying to get something put together for Toy Fair that opened. I was there Friday, Saturday, Sunday, trying to get something working for the Monday opening of Toy Fair. Richard brought in a couple people from mechanics, and they just put a bigger motor on this. I didn't have time to get the electronics into the toy, which was the plan. The mechanics was just behind for a whole bunch of reasons that I didn't have control of. And so we got enough working that it said like 15 phrases. You touch the back, and it was a very crude prototype. And the electronics, I had to run a long cable down and tether the electronics because I never had time to get it to fit into them, because I'd never had the mechanics until that was not fun. Real interesting story. And there's whole lots of things tied with that, all kinds of things. But anyway, got enough working. Oh, and so they're going, okay, David, there are going to be cameras that take a picture of this. And as soon as the cameras got in the area, it didn't work. And they're going, you got to do something. And it was only rub the back, it purred, feed it. There were 15 phrases, it did like 6 things. It was like as far as I was, it was really a dysfunctional Furby, but it showed enough. And so I ran. It's the oddest thing, and they remember it. I ran into the room where everybody was eating their little lunches and stuff, and they had some aluminum foil. And I just grabbed a roll of aluminum foil and wrapped it around all these cables and stuck a pin into the ground of an outlet and grounded it. It shielded it, and when the cameras showed up, it started working enough. And everybody's just screaming and yelling, and it's just like this turmoil, and it's just like, so.
Because at this toy fair is where you'll
the orders are
secure
placed.
the orders from the retailers, which will decide, if you go into production or at what scale you go into production. So it's a real do or die moment.
It is absolutely do or die. The other thing that's very interesting is I didn't know at the time, but contracts were being signed on Sunday night so that they would steal a little limelight of the opening of Toy Fair, that Hasbro was acquiring Tiger Electronics. They didn't even know what Furby was at the time because it was just being shown. But Randy Riskman, the president of Tiger, was saying, this is going to be like your big bonus in buying Tiger. He had great confidence in both me and the product. And so it was announced Monday, and Toy Fair opened, and they took enough working stuff to get 1 million orders for Furby from Toy Fair.
Now, which is maybe 4 times the minimum run for a product of this type,
yep.
as you're saying.
Yep.
So from the orders, a great success.
They said, cautious success, because they knew they didn't have a product yet. So the real development of Furby started in February, and I told you there's dozens of ways that Furby failed. I don't think Tiger was great to work with. I don't know that they had the resources to throw behind the mechanics that needed to get done for the real Furby. Hasbro did. Hasbro, and there are some brilliant people that were able to get the mechanics done. So I had to develop the real electronics, work with them on the real mechanics, and start writing code in February. And all of this was released in July. So these things in the internet that talk about 9 months of development cycle and all, no, it's 5 months really. And from the original model, Hasbro has said the faceplate remained, nothing else, So it was hectic, to say the least.
So when you say it was released in June, it was released to manufacturing?
Yes, July, actually. The code, yes. The code was released, I may have said June, but June, it was July. The code was released for manufacturing. The mechanics was released a little bit before that because they had to start doing the tooling. And the goal was to do a late release, because normally you would start shipping toys in June and July. Because there's, the 6 weeks on the boat and all of these, and there's the cube size and how many in a cube and how many you can ramp up and all these details. But we released the code, and the mechanics was already, getting released. Because to develop the code, as I mentioned, I had to have 6 to 8 models that were running for 6 weeks to 8 weeks during that process of the puppeteers doing their work and encoding the data structure. Right. So it was all done, and the code was released for them to start the final, making units, do a pre-production run, and then start running units for release in October, which meant they had to pay premiums for shipping, and they had to pay premiums for, so it was really a breakneck pace for all of this.
With the orders coming out of Toy Fair and the kind of royalty arrangements that you had made, could you feel a sense of relief then about, the pressures that had caused you to push for the project? Like, was it gonna?
That's a really interesting question because I have this personality flaw, I think, and what it is I had been in business long enough and had various jobs where a company went bankrupt owing me money. My wife and myself never counted the money until the check cleared. And I'm going to tell you something else was interesting. Randy Riskman, the head of Tiger, who then was bought by Hasbro, had great confidence in this. And so much to the tune that he had set up the manufacturing of 4.5 million units when only 1 million was actually ordered. And he did something he had never done before. He said to me, David, in the 17, 18 years, he's never had an inventor come in, do the costing, do the hardware, do the software, set up production. He said, this is going to be a success for you. Now this is in months before all the royalties were reported, because I was supposed to get paid like January, probably the first time. He wrote me a check for $100,000 and gave it to me. My wife and myself had the interesting reaction in retrospect. We didn't go out and celebrate. We didn't go out and have a steak dinner. We opened up a savings account and put it in and just put the check. Because I treated it like that may be the only check that we get. And you know what? That is close enough that we will pull off the surgery. And that's...
Well, that must have been a great feeling to be able to do that. I mean, it is the plan working out, but of course, the market reaction is, please describe the market reaction.
Well, in my contract, there's a clause that talked about how much we wanted them to spend on advertising budget. They later quickly came back and said, we don't think we need to spend this money. So the product blew through the roof. Instead of the million, they shipped 4.5 million units between October and December of that year. And yet, at the same time, there was some behind-the-scenes grumbling and news reports. It was like, well, they had held back on production so that it would make it a more successful product. Yeah, and scarce and all. That never happened. And ultimately, the first time around, by the time we added the Japanese language and Italian and French and Spanish, and and then Furby babies and so on and so forth. The first go-around was 48 million units. And then the next unit was another, give a total of about 68 million units worldwide.
48 million.
Yeah.
And then 68 for the follow-on.
It's a total. Another 20, yes, a total became 68 million. And then later, we were hearing numbers because they did the Furby and all the languages, and then the Furby baby and all the languages, and I was involved in all that. Then Hasbro did another release with my technical consulting, although sometimes there's more or less of that, and they released a Furby that didn't do quite as well. They released another Furby in 2012 that did very well again. It had LCD displays and face, and then they re-released the product again in 2016, I believe. But last time I heard, it may be, I don't know exact numbers, but something like 72 to 75 million worldwide.
Collectively over all of that.
Yeah.
And have certainly your intellectual property, but also your patents and designs and all of it have been relevant throughout that entire
period of time.
That entire run. You haven't, in other words, you didn't have Hasbro acquire,
That's correct,
all of
but
that.
This is where Richard, and having somebody that knows the toy industry even better than I did, is important. And so here's what happened. In the verbiage of the contract, although we brought the name Furby there, because this was Tiger did this, because they put so much money and advertising behind it, they own the word Furby. So even if patents expire, as long as and Furby is considered the second most worldwide recognized brand for toys after now so we'll have to figure out if you're supposed to keep this or not. But after Barbie, Furby is recognized. You can go to the Greek islands, you can go to Thailand, you can go to India, you can go to China, and Furby. So it has value. So as long as they call a product, patent or not, part of the Furby brand, the contract has me getting paid royalties.
Well, that's wonderful. Congratulations.
Yeah, thanks.
And I would love to hear you reflect on, it's almost like Furby became a cultural craze. You know, I don't know what the right term for it. It became a cultural phenomenon, that's for sure. Could you just, I would love to hear your reflections on, you know, why you think it became so.
In one fashion, I'm going to take credit, and in the next way, I'm going to remove me taking credit, because here's what I believe happened. Well, now, the phrase Furby, because in one fashion, much to some people's love of it and other people's not caring for it so much, is Furby talked a lot. And so they referred to politicians or movie stars that were very, very chatty as like Furbies, you know. And, but here's what I think the magic act worked. Here's what happened. I personally believe you couldn't ask for anything better. People added their own imagination to the toy, and it made it become better than what I had created. They became part of it. There's a couple odd things that happen. So normally you design a product and you expect a certain number of rejects, of things that are sent back. Furby had the lowest for the complexities of an electronic product like itself that they had ever experienced in the history of Hasbro. And so they had a hotline if you had trouble with a Furby. And so here's what started happening. Well, you know, way low, his ear's not moving so good. Well, you know, send him back and we'll give you a new toy. I don't want to send back way low. You know, he's kind of cute. I'll keep his like little ear that doesn't move so much. So they were keeping a droopy eyes or an ear that didn't move because they had bonded with Waylo or Utai or whatever their Furby name was. There were people that called and said, well, he's not working anymore. Okay, did you change the batteries? Oh, I forgot he's got batteries. I got wonderful letters from, now it came to Hasbro, and a few of them got channeled to me, and one was for a school for the unsighted in England. And they said, did you develop this toy for the unsighted children? I went, I'm sorry to say I didn't specifically, because they can interact with it and they love it. And I had letters from 5 or 6 family members that had someone with autism. And the child talked for the first time and related with Furby. How does it get any better than that? Then there were reports from a couple, you know, people in the Hollywood area that after their, you know, little rendezvous where they had a few drinks and a nice dinner, they went to sleep and Furby woke them up when their curtains were on fire. Bright light, bright light. So we had and then we had the NSA. And ultimately, the guy that had it banned from military installations, years later, I met him at a conference thing that I go to. He goes, well, you know, I'm the guy that banned it. I said, yeah, thanks for that. It was a lot of free advertisement. So, but you got to talk to me about that. It doesn't really learn, you know, and repeat things. But yes, it really just took on a life of its own. And people, in fact, there was, and I've forgotten the name of the group, but they were just avid Furby collectors, and they took what they called Uncle Alo, and they sent him from the U.S. to like Italy. and then the person put stuff on him of being on vacation in Italy and mailed it to France. And so he went all the way around the world. And when he came to California, I hosted Uncle Alo for a while and took some pictures and sent him on his way. That's the kind of stuff that was just going on. And I could have never, ever predicted that or expected any of that. But again, I think the main thing is that I didn't project what I want Furby to do with you. I wanted Furby to be what you thought it was, what you inferred it did. I had somebody that said, hey, thanks for, because he said Elohim and a couple, he said Alo instead of Alo, instead of little words. He says, he really helped me get through my, when you have your, bar mitzvah, that age, and you have to, all that preparing. He goes, and Furby helped me do that. That's like, wow, I don't know how he did that. And I heard these stories, and you know what else is really, really great fun, is they were all happy, they were all good news, they were all, autism and unsighted, and I mean, how does it get any better than that? It is just, it's just a privilege to be a small part of that. And again, it was the imagination of those that became attached to Furby. There was a pool. I didn't participate in betting on Furby, but of what was the largest group of buyers. Yeah. And initially, people thought, it would be girls 8 to 10 or 7 or whatever. Or what? Number one, women from 45 older. I heard about parties where 45-year-olds were sitting on the ground with their Furbies talking to one another, but they collected them because they wanted the one with the polka dots and the one with the stripes, and it took over that whole thing of like the Beanie Babies that whole collecting all the. So they were one of the largest. Young women in the 18s to 23 was another large market, and interestingly enough, of course, girls and boys. And then I heard a story of a father that says, "What'd you buy my son?" "It's a Furby." "Furby's a doll. I don't want my son having a doll, And so he took the Furby and put it. "You sit over there." Well, Furby sat there for a while, and he got bored. He goes, "Me bored," whatever, right? So he goes, "What?" The father picked it up and started playing with it, and they couldn't get it out of the hands of the dad, and he bought the kid a new fur. So I keep hearing all of these, during the period of time from '98 to 2000, whatever, 1, 2, 3, 4. So.
Well, it's fascinating to me to think about the longevity of the toy. These more current releases. And, certainly there's been a lot of development in electronics, since you first created a Furby. But, in terms of like an interactive robot intended for entertainment, I could be wrong, but to my awareness, there hasn't been a successor that has been as successful, and maybe it's precisely about what you were talking about. It's not so much, it's the appropriate amount of mechanics and electronics and compute and programming to do this magic trick more so than anything else. So maybe it's less about, certainly you were doing a lot of tricky things to make Furby have the performances it does at a certain price point with a certain technology, but it's almost about what's fascinating to me to think about, it's more like your design approach about evoking other people to project and imagine and relate to the device. That seems critical. Or else we would have seen somebody come along with Moore's Law and all this other technology and have something kind of that would have surpassed it in the category.
I believe it's a combination, and one of the strongest things you've discussed already, and here's the combination. As far as the technology goes, there's a lot of things that have happened that I've never discussed. For example, how do you get the battery life? How do you get the battery to last so long? It's not supposed to last so long. There's a trick where when Furby wakes up, Furby can dance, so he tips from down to up. I measure the duration of time that it takes. I calculate battery life. There's a lookup table. And what happens is there's something called pulse width modulation where you can control the speed. Well, what happens is I wanted the Furby to operate down to 0.9 volts per cell. That's considered a dead battery in the toy industry. And the toy needed a certain number of hours to be considered acceptable in the toy industry. And there was a lot of concern early on. But by doing pulse width modulation, I basically keep the battery low when the batteries are new, and so everything works. At the lowest battery and there was a lot of things done to just achieve that, hardware-wise and software-wise. And as the batteries die, I turn the pulse to the higher voltage for longer, and eventually when the batteries are around 1.1 to 1 volt per cell, I don't use pulse width modulation. And it also keeps the mouse synchronized with the speech. So there's all of those kind of details, and using the puppeteers to make it match. Here's something else that happened. When Furby also was showing up, there was a little trick that was done to get two motions for one. There is an eyelid that moves. And the eyeball, because of friction between the eyeball and the eyelid, kind of either leads it or recedes it depending on the motion, and it makes it look alive. Well, the tolerances weren't tight enough, and the eyeballs were just dropping. And it looked like this. And it was like, he looked dead to me. And there was a discussion where they're going, we don't have time, we can't fix it. I said, I'm sorry, if you don't fix the eyes, you don't have a product. Yeah. It doesn't look alive. And it was so I stayed up, I was so worried, I stayed up all night. I'm going like, how, because they said, no, we're not doing it. I said, do I pull the license? What do I do to get them to take this seriously? And so I called Randy at like 5 in the morning my time, 4 in the morning, at like 7 or 8, Chicago, whatever it was. And he says, no, David, we're taking care of it. Well, after that, I heard, well, he looks at you, he looks alive. So it's all of these details combined with allowing the inference engine. I think in large portion, you are correct. Allowing the imagination of the person to take over is a big part of it. But there are so many aspects of this that toy companies don't have the stick-to-itiveness to do all of the disciplines involved in the mechanics and the programming and the production and in the production costing. I'll give you another example. Little did I know there would be 68 million Furbies. But like, for example, in the US, most engineers say, oh, a low-cost transistor is a 2N2222. Yeah. That's a garden variety. But you pay a premium for that because that is not only a switch, but it's an amplifier. So if I go get an 8050 transistor out of Asia, that's not an amplifier, but I use it in saturated mode to turn on a motor, I don't have to pay that little premium for testing the 2222 as an amplifier, because the 8050, I'm not going to use an amplifier. Why pay for it? Right. So I went through all of it and did all of that kind of hardware design to make it low cost. The other thing is I purposely made the toy originally came out between $30 and $35.95. And that's what $29.95 and $35.95. It could go as high as $39.95. But the point is, that's what I said it would cost. I did not want to have haves and have-nots at Christmas time. People that couldn't afford it. And so a lot of these products start crossing into like ABLE. You start talking like $500, $600, $1,200. It's no longer something that a lot of people can share and participate in. So And timing has to be right. That Tamagotchi, I have to say, must have really helped the way I was hoping. Yes, and my wife and myself were just talking about it in the last couple of days. It's like, because I kept expecting the next greatest and biggest and better and you know, and I thought I would like have led this like revolution of really fun, great creative, interactive toys. It just never materialized. And you're right, it's 21 years later.
I wonder if it's in part also due to, due to the rarity of somebody being involved in this business who is like yourself. You know, it's hard to find somebody who integrates these domains, you know, who, you know, had the experience of, you know, doing kind of like the deep costing down to, maybe we're just going to use a switching, non-amplifying transistor.
A tenth of a cent.
You know, down in a very deep fashion, also uncompromising about these trade-offs, the droopy eye, the problem with the ear. You know, I am wholly ignorant of, I hate to say it, of kind of the toy industry, but, you know, do you think it could also be that the structure of the industry does not afford participation somehow by, you know, a creator like yourself who would embody all these disciplines, you know? Is it rare? Are people like you doing what you did rare 20 years ago and perhaps rarer today? I just don't know.
Thank you. That's very kind. It's a very insightful because it's a combinations of things that you just talked about. Because I'm going like, you know, I know some really bright people, and I go to this, and now it's more publicly made aware of a Silomar microcomputer workshop. Yeah. Some of the founders of the industry, and you know, and the first computer chip, and designed the 8051, you know, and I'm going like, how do I fit in with all of this, and what happened? And there's some people I consider much brighter than I am. And they were very, very kind, because when I talked, and I've gone to this meeting for like 25 years, yeah. And finally they said, Dave, how many people do LPC speech, or whatever, you know, I said, really high quality, low data rate. I said, there's about 12 people in the United States that really are known for doing, you know, how many people have had experience with puppeteerings in the, you know, and how many people have had experience with production costing at a toy, and how many people have this experience and that experience? And David, that's why you were able to do Furby. Don't belittle that combination of talents that allowed it to happen. The other thing is you cannot, it's just, whether it's luck or fate or whatever you want to call it, Tiger being so busy that I was left alone. So to have one person do the concept and all of this is unheard of. Okay. And for Hasbro, I love them dearly. They've in large portion allowed the success of the initial Furby by this mechanics team that they brought in, Peter Hall and names. There's just a list of people that ultimately went in a combination of talent that allowed the mechanics to get done. But for the most part, at Mattel and at Hasbro, things that are designed by committees.
Yeah.
And so everybody wants to put their little stamp on it or their little thing, and then it dilutes the concept. I mean, for example, I love what they've done with the latest Furby, but personally, I don't care for taking what's supposed to be a life form and tying it to an iPad. And an iPad, now your focus is now on that iPad, and there's little eggs hatching and little games playing in it, but now it's not Furby anymore. So, and I'm not a real strong of like getting the intelligence from somewhere else. I've stopped that multiple times. I wanted it to be all embedded and so that if you take it to the beach or you take it to McDonald's, it doesn't all of a sudden get stupid. Right. It's the same character that you've got attached to. So I think there's a combination of a successful toy product. And I think there's huge industries and huge opportunities in this whole deep learning and maybe senior care robots and all of this stuff that's going to be happening. But that's not the toy industry. The toy industry is very, very particular of what, consumers are very particular where they spend their dollars. And there's a lot of areas they can spend their dollars. And video games has changed the toy industry, much to their chagrin. But by being left alone, and my vision was able to be implemented. I think that is the rare thing today. I think that, don't get me wrong, there's great products like the Apple phone and designed by committee kind of works in a way, but you also don't see the strength of an individual, of a solid unified thought. The hardware taking place, the mechanics and the hardware and the software and the magic act and how much fortunate could I be? But the long hours. This is something else that was not known. Is that once it took off, I felt a commitment to Hasbro because they had helped me succeed. And for the period of time between 1997 and 2001, with all the Furby languages and all the Furby babies, I worked in excess of, for most weeks, over 100 hours a week.
Oh my gosh.
It was one person, spearheading all of that. And
but also keeping that kind of cohesive concept, the commitment to the sorts of quality that you want, or attention to detail, rather. I imagine it sounds like a lot of work, but it's also keeping it together.
No, and I learned, I've had all these experiences. At Mattel Toys, I worked on the CNC. And who I worked with was the voices of Mickey and Donald Duck and Disney characters. And I learned this really well. Now, the Mickey I worked with, he's probably retired now, looked like a football player, know. He's a big guy. And Goofy was there, and boy, that was a hard one. But they would have 3 people from Disney, and he'd go, "Hi, I'm Mickey," or "Mickey," and they go, "No, Mickey wouldn't have said it like that. Say it again." So they have so tight the control of the character of Mickey. Yes, I did that. I did that with the language. The first Furby, I did it with the language. I did that with what he would do and what he didn't do. I did it with the QA. I did it, yes. And I learned that because of Disney. And if you have a character, it has to be true to itself, because as soon as it falls out of character, it doesn't seem believable or real anymore. So, yes.
Well, we only have a few minutes left available to us, and I just wanted to talk about just sort of what this experience has meant for you since. It seems like you wound down your business in 2003, at least as it had been formulated. What has could you just briefly describe, your life after Furby, if
Yes.
you will, or life with Furby is maybe more appropriate?
Well, no, it's so when I talked about my first experience with a job out of the Navy, and I said they fell in love with something so much that they held on to it forever. Maybe this sounds odd, but Qbert, I let go. And Furby, this is 21 years later, I let go. People talk about it, people still, contact me about it, search me out and all that. But as much as possible, look, it was a huge opportunity, a huge success. But I hope there's more. Yeah. I want to move forward. So what I've been doing is for a long time after I got away from electronics because I'd been doing it from the age of 7 intensely until the age of, until the year of 2003, and a little bit too intensely between 97 and 2003. Furby was 2001. There were some other products in there. But anyway, the point is, in 2001, I got a pilot's license, and I did aerobatic training, and I got an instrument rating, and I flew 4 or 5 different kinds of airplanes, all different kinds of complexities, and some for aerobatics and some for travel and some for just sheer joy. Studied violin, studied cello, oil painting. I've doing experiments with artificial intelligence and music creation. Of course, I'm doing it. It's not something for a product because I'm too late to that party. There's too much of that going on already. But for my own interest, I'm doing a very, very small version of AI that interacts. So you analyze a song, create templates. And so there's a verse, there's a chorus, there's a bridge, intro, outro, and then do a program that analyzes verses and do a program that analyzes choruses. Not try to do this big, I'm a single person, try to do this big program that analyzes everything and creates a new song. And the goal is not for a computer to create music. I have no interest in that. I have the interest in a computer helping assist in the creation of music as kind of knowing some music theory or taking a bunch of songs of a certain type and doing a weighing system, and then I can say, well, here's my chord progression. So if it's more of a flavor of the Beatle tune, or if it's more of a hotel, like the Eagles or whoever, and adding that little variation to it, I'm interested in those things. I'm interested also in mentoring, and I help teach English for second language students and math and science, and try to help them find what they're interested in. So I stay busy doing things that are not necessarily for a commercial product, but I have no intention of stopping anytime soon. I just don't. I don't see that. Retirement for me is having the time to do exciting things that I'm interested in doing. And it is a challenge because in this day and age right now, there's insurances and bills and this and that and housemate and all those things that are distractions. It's hard to still have enough time in our busy lives to do those things that interest me. And I have this other thing is if I do something, I want to do it really, really well, and I want to. I love the being involved with it at such a level. This happens more with programming and with right brain things, where you just lose the awareness of your body, and you exist, and you're aware of the thought and the creation, and that process is just a wonderful experience. So, oddly enough, that's the long answer for as much as possible. This has been a wonderful opportunity and very exciting to relive this, but I haven't thought about it for quite a number of years. Yes.
Well, it sounds like a wonderful period of time to be able to just follow your curiosity and to be able to do, exactly the projects that you want to do now. So
thank you.
It's
Thanks.
a great